vectors question. We are told that A, B and C are points such that AB equals 3A plus 4B and AC equals 15A plus 20B. We need to prove that A, B and C lie on a straight line. Now, in order to prove that something lies on a straight line, so two vectors lie on a straight line, there are two things we need to show. So first of all, we need to show that they go through the same point. And secondly, we need to show that the vectors are parallel. Now we show, in order to show that vectors are parallel, they are multiples of each other. So parallel vectors are multiples of one another. Okay, so if you imagine the two vectors, or just imagine two straight lines. If they go through the same, if they are parallel, that means they are like never going to meet. And if they go through the same point, they must be on the same line because they're parallel. So they have to be going, they're the same angle from each other. And also they go through the same point, therefore the parallel line gets brought to this point. So that's why, how we can prove that points lie on a straight line. So AB and C lie on a straight line. Well, first of all, we know that both vectors go through A because it's A to B and then A to C. So they share a same point. And then secondly, can we prove they are parallel? If they are parallel, they are multiples of each other. So what we have to do is see, can we factorize one to prove that it's a multiple of another? So generally it's going to be the larger one. So is 15A plus 20B a multiple of 3A plus 4B? Well, let's see. AC could equal, so 3A plus 4B. How many lots of 3? So 5 times 3 is 15A and 5 times 4 is 20B. Therefore, AC is 5 lots of AB. So that's your second proof. So you say AC is 5 lots of AP. Therefore, they are multiples and therefore parallel. Okay, so the key thing with a parallel, with a straight line, is you need to show that they go through the same point and that they are parallel, which you do by showing they are multiples of one another. And make sure that you write this little bit here so you express how that vector is a multiple of the other vector, because this little thing here, that is the vector AB. So for this question, I am told that D, E and F are 3 points that lie on a straight line such that DE is 3E plus 6F and EF is minus 10.5E minus 21F. I am being asked to find the ratio of the length of DF to the length of DE. Now this is a key part. I'm being asked to work out the length of DF as a straight line and the length of DE. So remember that vectors, they give you both magnitude and direction, whereas a length, it does not have direction and it cannot be negative because a length is a positive value. So that's something to bear in mind for later. So a length must be positive. So let's have a look at what's going on. So I need to first of all work out what the vector DF must be in order to work out its length. So DF would be worked out by adding the two vectors DE plus EF. So DF would be 3E plus 6F plus minus 10.5E. So I'm just going to subtract it because a plus and a minus, remember, becomes a negative. So 10.5E minus 21F. So let's simplify that. 3E minus 10.5e is going to become minus 7.5e, and then 6f minus 21f is going to be minus 15f. So df, the vector, is minus 7.5e minus 15f, but as a length, the length df is 7.5e plus 15f, because it cannot be negative. So the length df is 7.5e plus 15f. The length de is going to be 3e. So let's put that as a ratio, 3e plus 6f. So what I want to do now is find the, what's the word? The multiple, my brain has stopped. Basically, what is de multiplied by to get to df? So there's a few ways you can do this. The easiest way is to just think, okay, 7.5 divided by 3, 7.5 divided by 3, 3's into 7, go twice, remainder 1, 3's into 15, go 5. So 3e plus 6f multiplied by 2.5 gives you 7.5e plus 15f. Therefore, this 7.5e plus 15f is 2.5 lots of 3e plus 6f. So the ratio would be 2.5 to 1, because it's 2.5 lots of that. But generally when you write ratios, you don't want to write them in decimals. So to turn it into a whole number, let's times it by 2, and that would become 5 to 2. So the ratio of the length df to the length of de is 5 to 2. Okay, so over here we've got a bounds question. We're told that p equals the square of 2e over f. The value of e is 6.8, correct to 1 decimal place, and f is 0.05 to 1 significant figure. We need to work out the upper bound for the value of p, and then give our answer to 3 significant figures. So the key thing with bounds, a lot of people, you can memorize how to work out the upper bound and the lower bound when you're using division and things like that. But if memorization isn't your key suit, then what you can do is just substitute numbers in to see what would work. So for instance, if you said that e was 5 and f was 2, and then reverse that, we could see which would give us the bigger answer. So let's say p would be the square root of 10 over 2, so p would be the square root of 5, okay? Or if we reversed that, p would be 4 over 5, or p would be the square root of 0.8. Okay, now the square root of 5 is going to be larger than the square root of 8, so therefore to work out the upper bound of p, I'm going to want the upper bound, so the greatest value of e and the lowest value of f. So let's just work that away. So to work out the upper bound with the division, you want the greatest value as your top numerator over the lowest value. And if this still confuses you, then what you can do, it's not going to be very time efficient, but what you can do is work out all 4 possibilities and then give your final answer as the upper bound. So let's have a look at E. 6.8, correct to 1 decimal place. Okay, so if it was 6.9 or 6.7, it would have rounded down. So therefore the bound within which it lies, the lowest value it could be is 6.75, and the largest possible value it could be is 6.85. Now obviously we know that it's not 6.85, we just use this for bounds, it's fine. So it would technically be 6.849 recurring, but instead of doing that, we just say, okay, we're going to say it's 6.85. So E is 6.85 to the upper bound. And then let's have a look at F. F is 0.05, correct to one significant figure. So to one significant figure, it would be 0.06 or 0.04. So once again, let's look at its bounds. The upper bound would be 0.055 and 0.045. So you basically say, when you're doing bounds, you think, what are the options for it to round up or down to, and then you find the midpoint. So for F, the lower bound is 0.045 for the lower bound. Okay, I don't need the other values because I already know that to find the greatest value for P, I need to do the upper bound divided by the lower bound. But once again, if you're not 100% confident, just do all of them if you have extra time and if this isn't your strong suit. So now I need to just enter these in. So P is going to equal the square root of 2e, so 2 times 6.85 over 0.045. So I've got a calculator, so let's just enter that in. That would be 2 times 6.85 over 0.045, and my final answer is 17.44833,644, and it says give your answer correct to 3 significant figures, so P would be 17.4. Circle the third digit, I look next door. If the answer is 4 or less, just ignore it, leave it as is. If it's 5 or more, I round up. So P is 17.4. In this question, I have been given a circle with a cyclic quadrilateral, and the whole weird shape forms a large triangle. So always try and visualize to yourself what shapes are actually formed, because that helps you later on. So first of all, I'm told that A, B, D, E is a cyclic quadrilateral, and that's important because if it's a cyclic quadrilateral, I can use the circle theorems. Now, in order for something to be a cyclic quadrilateral, it just means that each of its vertices of the quadrilateral need to touch the circumference of the circle. So if they hadn't told you that, you could have figured it out yourself by just thinking to yourself, okay, each of the vertices touch the circumference of the circle. So that's an important thing that we can use later. I know that ABC and EDC are straight lines, and I'm told that angle DBC is 60 degrees. So let's first have a look at what we can work out from here. So I know that this is a straight line. Therefore, I could work out this angle here. So angle ABD must equal 120 degrees as angles on a straight line sum to 180 degrees. Now, because this is a circle theorem question, anything that has angles or circle theorems, you're going to want to show all of your working and all of your reasoning. So all of the angle rules that you know. The only way you could have figured out that this angle is 120 is by knowing that angles on a straight line add up to 180 degrees. So just write it down. The next thing we can do is we were told that this is a cyclic quadrilateral. Now, in a cyclic quadrilateral, opposite angles sum to 180 degrees. So in a cyclic quadrilateral, opposite angles sum to 180. So I could figure out what this angle here is. Therefore, angle AED must equal 60 degrees. So I know that angle is 60 degrees. And then what other information have I been given? Well, I'm told that the size of angle EAB, so this angle here, to the size of angle BCD is 2 to 1. So whatever the size of angle BCD is, if that was X, this would be 2x. So I could label that accordingly. This is x and this is 2x. Now, the next part, so you've done like all of your working out from all of the information that you've been given. And this is the bit that catches most people out. You just want to try and visualize to yourself, okay, so I've sort of worked out everything I can within the cyclic quadrilateral. I've done my straight lines. I can't see anything further that I can do. So let's just have a look at what happens if I just zoom out and take a bigger picture. I know that there's a triangle that's formed. So I have this triangle over here. That's got the angle x, which is the angle I'm trying to work out. I know this is 2x, and I know that this is 60 degrees. So you then have an angle, and we know that angles in a triangle sum to 180. So that would be our next rule. So angles in a triangle sum to 180 degrees. You can form an equation using the ratio parts that you've been given. So x plus 2x plus 60 degrees must equal 180. Therefore, 3x plus 60 equals 180. Therefore, 3x must equal 120 and x must equal 40 degrees. So the last part, and the bit that kind of catches most people out, is just zoom out and think to yourself, okay, I've got a cyclic quadrilateral, but how can I look at all of the other lines? Oh, that's a giant triangle. Okay, so there's a few ways that you can do this question. There's a big clue in the question. It says, give your solutions to 3 significant figures. Well, there's two clues. It says solutions. Hopefully you already know anyway that any kind of quadratic, so ax squared plus bx plus c, is generally going to have 2 solutions because you factorize it into 2 brackets, and then it's the inverse of what you get in your bracket. Now, this I can tell, but maybe you can't. This isn't going to be a solution that you can factorize. You're either going to have to use a quadratic formula or do it another way, but it's not going to be able, well, I'll just show you. So if we expanded it, x minus 2 squared equals 3. So that would be x squared minus 4x plus 4 equals 3. Therefore, x squared minus 4x plus 1 equals 0. The factors of 1 are 1 and 1. There's no way I can combine them to make -4. So therefore, I have 2 options. 1, use the quadratic formula. And if you really like the quadratic formula, that's fine. You can just substitute your values in. A would be 1, B would be -4, and C would be 1. Or you just solve it, and because it's a calculator paper, you can deal with surds. So let's have a look at the solving it method. Nothing wrong with the quadratic formula. I'm just going to show you another way. So I know that x minus 2 squared is 3. To solve anything, I just want to get x on its own. So the first thing I do using BIDMAS, I'm going to square root both sides. So square root. So that's going to give me the square root of 3. And remember, this is especially super important for quadratics. What is the square root of 9? Well, the square root of 9 could be either 3 or -3, because a negative times by a negative gives you a positive. So therefore, this could be the positive or the negative root of 3. And then the last bit would be to add 2 to both sides. So x equals 2 plus square root of 3, or x equals 2 minus root 3. And those are my 2 solutions. You would have got there with a quadratic formula. Like I said, that's absolutely fine. This is just a slightly quicker way. And then all you need to do is just type that into your calculator. So 2 plus root 3 gives you 3.73205, or 2 minus root 3 gives you 0.2679 for blah, 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 blah. And it says give your answer to correct to 3 significant figures. So 1, 2, third significant figure, it's less than 4. So we're going to say 3.73. And over here, 1, 2, 3, the third significant figure is a 9. So we're going to add 1 here. So 0.26 8 are your two solutions. So here we've got a Venn diagram question, and these are super fun. They're just like Sudoku. They're just like filling in things and using the information that you have been given to try and find the missing piece. So let's have a go at this. A shop manager wants to advertise special offers on social media platform. The manager asks 100 customers which type A, type B, or type C they use. Of these customers, 4 use all 3 types. So there's my first piece of information that I can put into the Venn diagram. 4 use all 3. So if something uses all 3, it has to be at the intersection where all 3 intersect. So all 3 of these circles intersect here. So I'm going to put my first piece of information in the middle. I'm then told that 16 do not use any of type A, type B, or type C. So if they don't use anything that is in the Venn diagram, they need to sit in the little universe outside of the Venn diagram. So we're just going to place 16 over here. Sorry. 8 use both type A and type B, but not type C. So over here, this is the overlap, of A and B, and this would be things that were C as well. So 8 use both type A and type B, but not type C. So therefore I put 8 in there. So let's just tick off all the ones that I've done. Okay, 14 use both type B and type C. So over here you've got type B, over here you've got type C, and the space where they would use both of them, this is dangerous, will I be able to undo what I've done, would be this part here, this intersection here, because that intersects B and C. Now, I already obviously have, I knew that would happen. I already have 4 in there. So therefore, I need to do 14 take 4, which is 10, because this whole section must add up to 14, okay? Next, I've got 62 in total use type A. So here is type A, and all of this must sum to 62. So I'm going to leave that for later in case I have some information that I need to put into the intersection of A and C. And then it says all 20 who use type C. Okay, so I know that all of this must sum to 20. All 20 who use type C also use at least one of type A and type B. So, wow, I know that there's nothing in here and that everything, all 20 of type C must be in this bit. So 10 plus 4 is 14, which leaves 6 over here. Okay, so I filled that in. I know that over here, this must add to 62, all of A. So let's take away these parts here. So 8 plus 4 is 12, plus 6 is 18. And then 62, take away 18. Oh yeah, we have a calculator. So I don't even need to do that. 62 take away 18 is 44. Okay, so hopefully that made sense. We're just using the clues to fill in the missing pieces of information. And then we also have to think about how many must be in part B. So we know in total there are 100 customers. Okay, so we know all of our Venn diagram must add up to 100. So let's just quickly plug that into the calculator. 100, take away 16, take away 6, take away 10, take away 4, take away 44, take away 8 must be 12. So I've done 100, take away everything that's in the Venn diagram, and I'm left with 12. So therefore B must be 12. Okay, so now we are being asked to work out the probability from the Venn diagram. Now this question is frequently done incorrectly because people don't read it carefully and they don't know about what certain language means. So we are told that one of the customers is chosen at random, okay? But then we are told this key word here, which is given, okay? Now, given means that this is the new total. You shrink your Venn diagram. So originally there were 100 customers, but now it is given that the customer uses type A. So the customer has to use type A. So therefore it can be only out of these people. So whenever you're given the word given, it shrinks your Venn diagram. It's no longer the whole thing. So given that this customer uses type A, find the probability that this customer also uses type B. So our total is going to be out of everything that is inside here. So 44 plus 8 plus 6 plus 4 equals 62. So my probability is going to be out of 62. And then find the probability that this customer also uses type B. So here are all of the people that use type B. 8 plus 4 equals 12. So the probability that this customer uses type B, given that they use type A, is 12 over 62. So the key word here, pay attention to it, please. So in this question, I've got one of the trickier kind of a ratio questions. So let's have a look at what's going on. I'm told that there are 4 boxes on the shelf, A, B, C, and D. And the total weight of A and B put together is 3 times the total weight of C and D put together. So I know that the weight of A and B must be 3 lots of the weight of C and D. So I could just write that algebraically, or I could just leave it as 3 to 1. It doesn't really matter. So I know that whatever the weight of A plus B added together is, it must be 3 times the weight of C and D. So I need to keep splitting it into that ratio. Now the next piece of information I'm given is that weight of A is 2/3 the weight of B. So out of this ratio here, I know that whatever the weight of B is, so we could call B X, the weight of A is going to be 2/3 of that. So 2/3 of X plus X, which I could actually write as 3/3, just so that you maybe see what's going on, because X is a whole thing, value. Whatever B is the value that I'm relating to. A is going to be 2/3 of it. So if B was 30, A would be 20. But I'm just calling it X because I don't know the value. You can substitute values if you want to, as long as you keep it constant. So I know that 2/3 of X plus 3/3 of X, or a whole X, must equate to 3. So therefore 5/3 X must equal 3. And how could I figure out what X is? Well, I divide both sides by 3. So 3 divided by 5/3 gives me 9/5. Okay, so either, I'm trying to think, I'll leave it in fraction form. So I know that if X is 9/5, then I'll write it in all forms actually. The value of A, the value of B, the value of B would be 9/5 or 1.8. And then times that by 2/3 to figure out the value of A. That would be 6/5, or in decimal form, 1.2. So I figured out what the ratios of A to B must be. And that would be 1.2 to 1.8. So I've just broken that up into 2 parts, 1.2 to 1.8. And that is the ratio of A to B. Now what I want to do is do the same, but with this part here. So I know that the weight of C and D is going to be 1 part of whatever A plus B is. So I know that the weight of C is 75% the weight of D. So therefore, 75% I can write as 3/4. So if I give my value of D an algebraic form, so I'm just going to call dx because that's the value that I'm working with that I know as a whole. So if D is X, then C would be 3/4 X. And once again, I could write this as 4/4 X because what's 4/4? That's a whole. So it's the same thing, but just so you see what's going on. So 3/4 x plus 4/4 x must equal to 1. Add them together, 7/4 x must equal to 1. So therefore, how am I going to work out what x is? I'm going to divide both sides by 7/4, which leaves me with 4/7. So therefore, C and D, well, D must equal 4/7, or if I type that into my calculator, 4/7 is probably going to be, yeah, so 0.57142. It's not a nice easy decimal, so I'm going to leave it in fraction form. And then 3/4 of 4/7 is going to give me 3/7. And once again, that's probably going to be a long decimal. So I'm going to choose to keep this in its fractional form. So let's rub this out, and I've got all of my key values here. I know that A to B is 1.2 to 1.8, or I could write it in fractional form, 6/5 to 9/5. And then C to D must be 3/7 and 4/7. So I've got all of my ratios in this form in a way that they relate to each other, because I started by splitting them up into the ratio 3:1, and then using this ratio I split them up into their A and B and C and D correspondence. So now this is the full ratio. However, it doesn't actually say to simplify it, but we're going to do that anyway. So let's just have a go at seeing what we'd need to do. So A to B to C to D is 6/5 to 9/5 to 3/7 to 4/7. Now, in order to simplify this, I want to turn them all into whole numbers. And what's the best way of turning them into whole numbers? Just multiply by the denominator. So let's start by multiplying the whole ratio by 7. So 6/5 times by 7 is going to give me 42/5. 9/5 times by 7 is going to give me 63/5. And then the reason I've multiplied by 7 is because if I multiply anything by its denominator, or its reciprocal of the denominator, look what happens. So 3 times 7 is 21, divided by 7 ends up with 3. So I basically eliminate the denominator. That's why I multiplied by 7, to get rid of these denominators here. So it'll become 3 to 4. Then what can I do? Well, I can multiply the whole equation by 5, because both of these parts have a denominator of 5. So that would be 42 to 63. 3 times 5 is 15, and 4 times 5 is 20. So that is how you would find the ratio. Now, there are so many different ways that you can do this question. This is just one of the ways. If you still ended up with this ratio, then I'm sure that you'll wait. Okay, so some nice solids we're given here. We're told that a solid cone is joined to a solid hemisphere to make the solid T shown below. And we're also very kindly given the formulas for the volume of these shapes. Now, you're told that the diameter of the base of the cone is 7 centimeters, and the diameter of the hemisphere is also 7 centimeters, i.e. they're like literally attached. So the total volume of T, which is the shape, so this is called T, is 120 pi, and the total height of T is y centimeters. Calculate the value of y and give your answer correct 3 significant figures. Okay, so let's think about what's happening here. We know the total volume, okay? So we know the volume of T. And how do we create the volume of T? Well, we create the volume of T by working out the volume of the cone, which we know is 1/3 times pi times r squared times h. Okay, I'm just using this formula here, plus the hemisphere. So hemisphere is going to be half a sphere. So if the volume of a sphere is 4/3 pi r cubed, the volume of a hemisphere is going to be 4/6 times pi times r cubed. I've just multiplied it by a half. Remember, timesing by a half is the same as dividing by 2. Okay, so this is my long complicated formula. And let's see what I can do. I can substitute the volume. So I know the volume is 120 pi. And I know that must equal 1/3 times by pi times by r. So r is the radius. So we've been given the diameter. So therefore the radius is half the diameter. So that would be 3.5. So 3.5 squared times by h. Sadly, we do not know what h is. Plus 4/6 times by pi times by r cubed. And r is once again going to be the same, 3.5 cubed. So what we can do when we're doing things like this, and I should have probably left more space, but hey, what can you do? Is we're just looking at simplifying this, rearranging it so that you can find the value of h. Okay, so all I have done here is plug some values into the formulas that have been given. So even if this question, you're like, I don't know what to do, just look at it, look at the formulas you've been given, look at the information you've been given, and plug the formulas in. So next, what can I do? Well, all of this is numerical, so I can figure out what this is and subtract it from 120 pi. So if I did 120 pi, take away 4/6 times pi times 3.5 cubed, what would I get? So I'm going to do that bit by bit. So I'm going to type into my calculator 4/6 times by pi times by 3.5 cubed. I've got a new calculator, so all of the things are okay. So that's how I type it into my calculator, and then I get an answer which gives me 343 over 12 pi. So I'm going to do 120 pi take away answer. Okay, still getting used to this calculator. So 120 pi take away answer, and then it gives me 1097 over 12 pi. Okay, so what I've done is I've subtracted this from both sides of the equation. Okay, so I'm just left with this bit here now. So this must equal 1/3 times pi times 3.5 squared times by h. I'll just get rid of everything over here so that I can move over here now. Okay, so I'm just rearranging it, and it's just got more numbers than usual, but you've got a calculator so you can do this. Okay, so what can I do then? I can simplify this side of the equation here. So if I simplified it, so 1/3 times by pi times by 3.5 squared gives me, so I'll move over here, 1097 over 12 pi equals 49 over 12 pi times by h. Okay, so can you see I've simplified all of this, so I'm just left with some numerical stuff multiplied by h. And how do I get h as the subject? Well, I'm just going to divide both sides by 49 over 12 pi. Okay, so you do exactly the same as you would with simple algebra, it's just it's a fraction and it's got pi in it. So let's do that. So 1097 pi over 12. I miss my old calculator. I don't like these new ones. Okay, take away 49 pi over 12 equals, oh, sorry. The calculator distracted me. So I'm dividing it. So I divide it and it equals 1097 over 49. Okay, so h equals 1097 over 49. Now, with the old calculators, and this is why I really miss them, you had this SD button and you just clicked it and then it converted it. Now what you have to do is you press format and then you have to go down to decimal. And this might be me not knowing the calculator very well. So if you know if there's a quicker way to do that, then please let me know in the comments. So h must be 22.387751. Okay, I've just converted the fraction into a decimal. So I figured out what h is. Now let's see what I can do next. And h is going to be in relation to my cone. Okay, so h is this part here. So I know that that must be 22.3877. Now I also know it's a hemisphere, so I know that there must be a radius going from here to there. And I know that the radius of this shape is 3.5 because we spoke about that. So the diameter is 7, so therefore the radius is 3.5. And remember, a radius can go in any direction as long as it starts from the center of the circle. So the total height or length, the total of y is going to be h, which is 23.38 plus 3.5, which leaves me with, again, this SD thing is annoying, 25.887751, and it says give your answer correct to 3 significant figures. So that would be 1, 2, the third significant figure is here. So I'd say 25.9. Okay, so 25.9 is the value of y. So it looks like a complicated question and loads of people just skip it because they're like, oh, it's just a confusing shape. But all you have to do is use the formula that has been given to you, manipulate it a little bit, find the missing value and do something with it. Honestly, the more you practice these, the easier they will become. Okay, so in this question we are told that the diameter of the base of the cone and the diameter of the hemisphere are both increased. Okay, so this bit here in the shape is increased by the same amount, assuming the total volume of T, so the total volume of this like shape does not change. What effect would that have on your answer to part A? So remember, part A was the total height. So if we think about it, it needs to have the same volume and one part of it has been increased. So therefore the height or h or t, or what were we trying to find? We were trying to find y. So the total height would decrease because the volume has stayed the same. So if it stayed the same, then something must be smaller, because if something's bigger, if 2 dimensions are larger, then the final end product would be larger. Okay, so because the volume stays the same, the height must have decreased. So in this question, I'm being given a triangle and I'm being asked to work out the area of the triangle. Now, whenever you've been given a triangle, if you've been given a right angle triangle, you know that you can either use Pythagoras or your standard trigonometry, which is SOHCAHTOA. If, however, you have been given a triangle that does not have a right angle, you're going to have one of 3 options. You either use the sine rule, the cosine rule, or the area of a triangle. Now, the formula for the area of a triangle is half AB sine C. So this is something that you're going to have to remember. And whenever we're dealing with this kind of trigonometry, so not our basic trigonometry, things for a non-right angle triangle, what we want to do, the first thing is label all of our angles and corresponding sides. So in this case, when you have a big letter, it represents an angle, and a little letter represents a side. And wherever your angle is, the opposite to that is going to be your little letter side. So in this triangle, I want the given angle to be C, because that's what I'm going to be using. That's the only angle I've been given. Therefore, this side here is going to be C. And this side here would be A, and this would be B. It doesn't matter which one's which because we're just multiplying, so you could have labelled them the other way around. Now, all I need to do is substitute into the formula. A half times by A which is 11.2, times by b, which is 4.3, times by sine 118. And I just plug that into my calculator. So 0.5 times by 11.2 times by 4.3 times by sine 118 gives me 21.26137,804. And I'm told to give my answer correct to 3 significant figures. So the third significant figure is this over here. So I'm going to look next door. If the number is 5 or more, I round it up, I add 1 more. So that would be 21. Okay, so here I've got 2 different ratios that have 1 variable in common. So what I can do is I can write them in the way that I want them to finally be, x to y to z. So I know that the ratio of x to y is 2 to 3. Then I know that the ratio, and this is where it gets, this is not a simple standard kind of combining ratio questions. I know that the ratio of 2y to z is 4 to 5. So 2y is equal to 4. Therefore, if 2y is 4, y must be 2. So the ratio of y to z is going to be 2 to 5. Okay, so then I know the ratio of y to z is 2 to 5, and I can write it in this table here. In order to combine the ratios, you want your common variable, in this case this, to be equal. So you find the lowest common multiple of the variables. The lowest common multiple of 3 and 2 is 6. So I multiplied this ratio by 2, and that is going to be 4, and that is going to be 6. And then I multiplied this ratio by 3, because 2 times 3 makes 6, and then 5 times 3 makes 15. So x to y to z would be 4 to 6 to 15. Okay, so in this question, I'm being asked to enlarge shape P by scale factor -1/2 with center of enlargement 0, 0. So just a reminder that a negative, when you're enlarging by a negative scale factor reverses the direction. So when we're normally doing enlargements, what we do is we think, okay, how do I get from my shape? I go 2 and then 3 up, and then I'd do the same in this direction. So I always start from the center of enlargement and I go towards my shape. Now, when it's a negative scale factor, what I do is I start from the shape and go towards the center of enlargement and beyond. Okay, so that's for the negative part. And then a fractional part, well, a half just means that whatever the shape is, it's now going to be a half of that. And whatever the distance from the shape to the center of enlargement is, it's going to be half of that on the other side. So let's put this into practice. So fractional just means half of the shape. So each side is going to be half of its original length. So let's pick this point and I can label that with an X. What am I doing to get to my center of enlargement? I'm going down by 3 and across by 2. So I then need to do half of that. So down by 1.5, because that's 3, that's 2, so I half it. Down by 1.5 and across by 1. So that is where my new little X point is going to be. Let's do the same with this point, and I'll just do it as a circle. What am I doing? I go down by 3 and across 4 to get to my center of enlargement. So I'm going to do half of that. So half of 3 is 1.5, half of 4 is 2. So my little circle is going to be there. And for my last point, what shall I do? I could do a triangle. So this little point here, actually no, I'll do a star. That's much nicer. So a little star. What's happening? I go down 7 and across 2. So I'm going to have to do half of that. Down 3.5 and across 2. So my little star is going to be there. And once you've got all of your points, all you want to do is just join them up and label your image Q. So this is going to be Q. So the key thing is just with a negative, when you're enlarging by a negative, you reverse the direction. And with a fractional, it just means you multiply each side by a half. And the distance as well. And that's okay. So here we have a really fun, nice coordinate problem. I'm told that ABCD is a rectangle. So this shape here is a rectangle, which means that all of its, well, not all of its sides, but this side and this side will be parallel, and this side and this side will be parallel and also equal. I'm also told that A, E, and B are points on the straight line L. So this is the straight line L, and it has an equation of, let's rearrange that. So you always want your straight lines to be in the form y equals mx plus c. So let's rearrange that. Let's take x from both sides. So 2y equals 12, take x, and then I'm going to have to divide by 2 to make y the subject. So y equals 6, take away a half x. I could rearrange that to be y equals minus a half x plus 6, but it doesn't really matter. What I'm looking for is the gradient. So generally you're going to be given 2 lines, and one of them you're going to use in order to work out the gradient of it. So I know that the gradient of line L is minus a half. I could just write this here as the whole equation, y equals minus a half x plus 6. So I know some information, and the gradient is minus a half. Now, what have I actually been asked to do? So I was given that information and I used it, and I'm told A and D are points on the straight line M, and that AE equals EB. So this length here is equal to this length here. So essentially, if AE equals EB, then that must mean that this is the midpoint, because they were equal, and this must be the halfway point. So I know that is the midpoint of this line. What am I actually being asked to do? I'm asked to find an equation for M. Okay, so let's think what we need to do. We already know the equation of this whole line here. We know that that is y equals minus a half x plus 6, and I'm being asked to find this line here. Now, it looks like a perpendicular line. How can I prove that it's perpendicular? Well, this is a right angle. I mean, this is a rectangle, so therefore its angle is going to be a right angle. So I know that line M and line L are perpendicular. And what do you know about perpendicular gradients? Hopefully you know that the gradients of perpendicular lines multiply to make -1. Okay, so either you know that, or you know that they are the negative reciprocal of each other. And all that means, let's say you had a gradient of 3, the negative reciprocal would be -1/3, because if you did 3 over 1 times by -1 over 3, 3 times -1 is -3 over 3, which would simplify to -1. Okay, so the negative reciprocal, whatever you have, if it's a whole number, you turn it into a fraction, flip it, and then whack a negative sign in it. If it's already a negative, then it's just going to be the positive version of that reciprocal. So I know that the gradient of line L is -1/2. So what is the negative reciprocal of -1/2? So I know that it's going to be positive. And what do? I just flip this fraction around. So it'd be +2 over 1, which would simplify in layman's terms to just 2. So I know that the gradient, where can I write this? I'll just write it here because we don't need this anymore. The gradient of line M, which I'm trying to find, is 2. How do you write an equation of any line? You write it as y equals mx plus c, where m represents the gradient of the line and c represents the y-intercept. So what could I write? Well, I can fill in the gradient, which is 2. So the first part would be y equals 2x plus c. Now what I need to do is find out what the y-intercept is, which is where the line crosses the y-axis. So how can I do that? Well, let's have a look at the information I have. I know that Oh, I shouldn't have deleted the other one. What did I say the equation of that line is? It was y equals minus a half x plus 6. So that's my line L. If I have the equation of a line and I have a coordinate, I can use that to work out another coordinate. So over here, you know that B crosses the x-axis. Therefore, the coordinate of B is going to be 0 something. Sorry, other way around. It crosses the x-axis, therefore y is 0. So I could work out the x coordinate. How can I do that? By substituting 0 into this equation. So I'd say that 0 equals minus a half x plus 6. Therefore, if I took x onto the other side, half x equals 6, and it's a positive half because I've added a half x to both sides in order to cancel it out. So I know that half x equals 6, or I could write that as x over 2 equals 6. So times both sides by 2, and you know that x equals 12. So the coordinate of B is 12, 0. I then also know that I can work out this coordinate over here, because that is where the line crosses the y-axis. So that means that x is going to be 0, and I can find out the y coordinate. Once again, I substitute into the equation of the line. So I know that y is going to equal minus a half times by 0 plus 6. Anything times 0 is 0, so therefore y must equal 6. So the coordinate of E is 0, 6. So I now have two coordinates that I can work with. And ideally, I need to find out what the coordinate of A is, because sadly, my line M doesn't go through anything else. I could have also figured out what the coordinate of D is, but that's a different way, so let's just stick with what we've done so far. So I now know that the distance from here to there, the y distance is 6 and the x distance is 12, because this coordinate here is 12 and this coordinate here is 6. I also know that this is the midpoint, therefore exactly the same distance is going to take place over here. So the y coordinates are going to go up by 6 and the x coordinates are going to go left by 12. So therefore, this coordinate here must be minus 12 and this coordinate here must be positive 12. So now I know that the coordinate of A is minus 12, 12, and that is a coordinate on the line of y equals 2x plus c. So I figured out what this coordinate is because my line goes through it, and if my line goes through it, I can use the x and the y value and substitute it into my equation to figure out what c is. So I know that when x is negative 12, y is 12. So let's just substitute that in. 12 would equal minus 24 plus c. So if you add 24 to both sides, you find out that c must be 36. So if c is 36, my final equation is going to be y equals 2x plus 36. So let's just write it here as well. It's a little bit of a long-winded one, but you just want to think about what you can play with. We could have also worked out the coordinate of D here, but let's not worry about it. We did it this way. Could have been a quicker way. I don't know. Whatever way you do. Okay, so in this question, I am told that the equation, the cubic equation, has a solution between x is 0 and x is 1. So all that means is that the cubic graph must be crossing the axes between x is 0 and x is 1. And the way to prove that is, well, over here, x is 0. Sorry, y is 0. And anything above that, y is going to be positive. Anything below that, y is going to be negative. So if you can prove that between these two values, when x is 0 and x is 1, the y changes from a positive to a negative, then you've proved that there must be a solution between there. So what we do is we substitute the values in. So first of all, we'll put 0 cubed minus 3 times 0 plus 1 equals, and then 0 cubed is 0, 3 times 0 is 0, so that equals 1. So what we're hoping for is that the next part is a negative. So 1 cubed, take away 3 times 1 plus 1 equals, well, 1 cubed is 1. 1 take away 3 is minus 2. Minus 2 plus 1 is negative 1. So I know that the y values are going to be negative 1 and 1. So therefore, to show that there is a solution, you say there is a change in sign from 1 to negative 1, showing there must be a solution. Okay, for the next part, it's just a simple rearranging. Now, you need to show that the equation x cubed minus 3x plus 1 can be rearranged to give the equation they want. So let's have a go. So x cubed minus 3x, I'm just going to subtract 1 from the get-go, is minus 1. Don't panic if you see a negative, because there's a trick we can use at the very end. Then I know that they want to have an x squared, so I'm going to need to factorize that to get x out. So x squared minus 3 is going to be equal to minus 1. If I divide both sides by x squared minus 3, I'm left with minus 1 over x squared minus 3. Okay, so whenever we've got something like this, we never want to have a negative as our numerator. We just want to clean it up a bit. So if we multiply everything by negative 1, remember, if you multiply a fraction by the same value with its numerator and its denominator, it keeps it in the same proportion. So we've just fiddled with it a little bit, but it's the same fraction. Like if you had 3 over 6 and you times it by negative 2, that would be negative 6 over negative 12, but a negative divided by a negative is a positive, so you'd end up with the same value. 3/6 is a half, negative 6 divided by negative 12 is also going to be a half. So therefore, if we multiply the numerator and the denominator by negative 1, we clean it up a little bit. So minus 1 times 1 is 1. And x squared times by negative 1 would be negative x squared, and negative 3 times by 1 would be positive 3. And then we just rearrange it to be 1 over 3 minus x squared. So that one, slightly tricky bit at the end, but remember the little trick, multiply both numerator and denominator by negative 1, and you've cleaned it up. Okay, so for the next part, I am told to, starting with 0.5, use the iteration formula. So that's what I literally just rearranged to find an estimate for the solution of x cubed minus 3x plus 1. So x0 is 0.5, and I'm going to be plugging that into this formula. Remember, all this means is the original term, and all this means is the next term. So iteration is literally the formula that you use to work out the next term using the value of the previous term. So let's start with 0.5. So when you're using an iteration formula and it's a calculator, what you can do, type your first value in. So I'm going to press 0.5 equals, and then I'm going to write the fraction. So it's 1 over 3 take away 0.5 squared. I'm just putting 0.5 in, substitute it into this because xn, that's the original value, so that's going to be 0.5. So I'll write this into my calculator. I press equals, and that, annoyingly, these calculators, please, if someone has any influence, bring back the SD button. It's very frustrating. So 0.36 recurring. So is it recurring or? Either way, it doesn't matter, because what I'm going to do is, now that I've pressed equals, I'm going to go back using my arrow method and delete that, and then press answer, and then press equals. And that will tell me what the next term is. If this is too confusing, just do it bit by bit and substitute each value in. So that would be 0.34870,317. And now, because I've done it 3 times, if I just press equals, it automatically works out the next term for me. So x3 would be 0.3474144,945. x4 would be, let's press equals. Okay, 0.34730,625. Press equals again. is 0.3472971. So what you can see, and this is the cool thing about iteration, each time we're going to get closer and closer and closer to the solution. So what you want to do is get to a part where some of your solutions round to the same thing. So after the third term, we can see that all of my values are going to round to 0.347. So in this case, it hasn't told you to use the iteration formula twice. So you just keep going until you find that pattern. So you're going to say x is 0.347, and that is to 3 decimal places. Because to 3 decimal places, for all of these values, it rounds to 0.347. In this question, I have been given a lot of information about a triangle, told its coordinates. So let's just have a quick sketch of drawing this. It doesn't need to be super accurate as long as we think about what we're doing. So I've got the vertices P, Q and R. If you think about an axis, you know that everything in this quadrant is going to be positive x, positive y. Everything in this quadrant is going to be negative x, positive y, and so forth. So the coordinates of P are -3, -6. So that would be in this quadrant here. So that makes sense to have P right at the very end. The coordinates of Q are 1, 4. So if we imagined that maybe our line went like that, this makes sense that Q would be up here. And 5, 2, 5, -2. Well, my y, it wouldn't exactly look like this. So maybe I'd want my triangle to be like this or something. I don't know, but for the purposes of this question, it doesn't really matter. So we've got P, Q, R. It mostly makes sense because I know that this would be in, if I had my axes, this would be positive x and negative y. So it's roughly in the right place. So let's have a look at what's going on. It just helps to sometimes like sketch it so that you can visualize what the question's asking you to do, because I am then told that M is the midpoint of PQ. So I know that this is where M would be, and N is the midpoint of QR. Okay, so that would be where N is. And I need to prove that MN, so if I drew a line from here to there, is parallel to PR. Okay, well, that looks pretty good to me in terms of looking parallel, but let's have a think about what's actually going on. So in order to do this, I'm going to need to do quite a little bit of working out. So how do I prove that lines are parallel? Well, I know that parallel lines have the same gradient. So what I'm going to need to do is find out the gradient of PR and the gradient of MN. So how can I do that? Well, to work out the gradient of a line, I have to do the change in the y coordinates divided by the change in the x coordinates. And the shortcut way is saying y2 take y1 over x2 take x1, which just means the second y coordinate take away the first y coordinate. So let's have a look at these. The coordinates of P are -3, -6, and the coordinates of R are 5, -2. So let's start with the y coordinates. I'd say -2 minus -6 over, and then the second x coordinate is 5, and I'm going to take away -3. So -2 plus 6 is going to give me 4, and 5 plus 3 is going to give me 8, which is a half. So the gradient of PR is a half. Okay, now let's have a look at MN. Have I been given any information about it? Well, all I know is that it's the midpoint of these lines. So what I'm going to have to do is work out what the midpoint is. So what's the coordinate of Q? It's 1, 4. How do I work out the midpoint? Well, I can either, how do you work out the middle of anything? You add the values together and you divide by 2. So I could do -3 plus 1 divided by 2, which is -2 divided by 2, which is -1. So I know that the x coordinate would be -1. And if I did the same, -6 plus 4 is going to give me negative 2 divided by 2 is negative 1. So that coordinate is going to be -1, -1. If you just wanted to do it intuitively, you think to yourself, between -3 and 1, what's the difference? 4 divided by 2 is 2. So I'm going to move my x coordinate up by 2 values or down by 2 values. And the same for your y. Between -6 and 4, there's a difference of 10. 10 divided by 2 is 5. So you either add 5 from your lowest y coordinate or you subtract 5 from your highest y coordinate. Now let's do the same for n. So the difference in the x coordinates is 4. Half that is 2, so that would be 3. And the difference in your y coordinates is 6. Half that is 3. 4 take 3 is 1. So I now have the coordinates of 2 points on my line MN. And how do I work out the gradient? Well, I do it exactly the same way. I do the change in the y coordinates. So I'm going to do 1 take -1 over 3 take -1. 1 plus 1 is 2. 3 plus 1 is 4. And 2 over 4 simplifies to a half. So the gradient of MN is a half. Prove that MN is parallel. So I just say both lines have a gradient of a half, therefore they are parallel, because parallel lines have the same gradient. Okay, so here we've got a question that is asking us to solve something including algebraic fractions. So let's have a go and see what we need to do. Now, the key thing to bear in mind always is your basics. So in order to add or subtract fractions, they need to have the same denominator. Okay, so they need the same denominator. That is for complicated fractions, simple fractions, any kind of fraction you can imagine. So the first thing we want to do is look at these algebraic fractions and write them with a common denominator so that I can add them. So you've got 1 over 2x minus 1 plus 3 over x minus 1. Now, with algebraic fractions, generally the easiest thing is going to be to cross multiply them. So multiply the denominators by one another to get a common denominator. So over here, if I did that, I can create my new fractions. So what have I done to the denominator to turn it into this? I've multiplied by x minus 1. So the numerator must also be multiplied by x minus 1, because for a fraction to be kept in the same proportion, the numerator and the denominator need to be treated the same. And then what have I done to this fraction? I have multiplied it by 2x minus 1. So that would become 3 brackets 2x minus 1. The quick way would be literally to do this, where you know that you're going to be multiplying it like that, as long as you understand why. So then what I can do, they are both with the same denominator, so I can just add the numerators together. So x minus 1, let's expand the brackets, plus 6x minus 3 over 2x minus 1, x minus 1. Let's simplify that. X plus 6x is going to give me 7x, and minus 1 minus 3 is minus 4. So now I have got a nice fraction. Well, some of you might not think it's that nice. And it is equal to 1, don't forget that part. So what can I do next? Well, I have brought it together, and this is asking me to solve. When I'm being asked to solve something, that means I need to find the value of x. Generally, if it's something complicated like this, you're most likely going to be getting it in the form of a quadratic. So I can multiply both sides by the denominator so that it's no longer a fraction, and I end up with 2x minus 1, x minus 1. Once I'm here, I just need to manipulate the algebra a little bit. So let's expand the brackets. That would give me 2x squared minus 2x minus x plus 1. I can simplify that. So that'd be 7x minus 4 equals 2x squared minus 2x minus x is minus 3x plus 1. Now you've got your quadratic, but in order to solve a quadratic, you must make it equal to 0. Okay, so in order to solve the quadratic, it needs to be equal to 0. So let's manipulate it. So one of the sides is 0. So let's add 4 to both sides and then subtract 7x. So 0 would be 2x squared minus 10x plus 5. So here you've got a quadratic, and if this was a super nice question, then you would just be able to factorize it by putting it into brackets. However, it's not quite so nice, and a little hint to that may have been this over here, which may perhaps indicate to some of you that you need to use the quadratic formula. So let's write our expression out. 0 equals 2x squared minus 10x plus 5, and then the quadratic formula, which is x equals minus b plus or minus the square root of b squared minus 4ac over 2a. Now, if you find the quadratic formula a little bit tricky to use, the best thing to do is start by actually saying what your values are. So every quadratic is written in the form ax squared plus bx plus c, where a is the coefficient of x squared. So in this case, a is going to be 2, b is going to be negative 10 because b is the coefficient of x, and c is the number on its own, so c is going to be 5. So let's plug that into the formula. So x must equal minus 10, because b is minus 10, square root of minus 10 squared minus 4ac over 2a. So let's simplify that. Minus 10 is just going to be positive 10. Oh, sorry, I forgot to put plus or minus the square root of minus 10 squared is going to be 100. And 4ac, 4 times 2 times 5 over 2 times 2. So what does that then give you? You've got x equals 10 plus or minus the square root of 4 times 2 is 8, times 5 is 40, 100 times, take away 40 is 60 over 4. Now, we've got a third, okay, so we've simplified it. So if you've got this far, that's amazing. But we want to look at the question and what it's asking us to do. So it's saying, give your answer in the form p plus or minus the square root of q over 2. So we know that we want to simplify this fraction. So let's have a look at what we can do with the third first. Now, once again, if you did get this far and you're like, okay, this is as far as I can go, that's great, well done, but have a look and see if maybe you could get a bit further. So let's look at simplifying the third. So square root of 60, how else could I write that? Well, I'm going to try and look for the largest square number. So square numbers are 1, 4, 9. Let's see if 4 fits into it. So I know that I could write that as root 4 times by root 15, because 4 times 15 makes 60, which is the same as 2 lots of root 15. So I could then rewrite this as x equals 10 plus or minus 2 root 15 over 4. And now it's a lot easier to divide the fraction and turn it into a fraction over 2, because I could divide each part by 2. If I was dividing the root 60 over 2, I'd have to split it into root third, okay. So we've got each part divided by 2, x would be 5 plus root 15 over 2. So that is what your final answer should be. But if you've got to here, then that is still pretty amazing. Just always with a third, think how can you simplify it? And then it makes everything else easier. Okay, so dealing with standard form, when you've got a question like this, there's a few things that you can do. So 2.1 times by 10 to the power of 7 is being divided by 3 times by 10 to the power of minus 5. Now what we can do, because remember that divide sign is this divide sign here, it's just another way of writing it. When you've got fractions, if their numerators are a product and their denominators are a product, you can separate them. So I could separate that into 2.1 over 3 times by 10 to the power of 7 over 10 to the power of minus 5. And then it just makes it a little bit easier for me to see what I'm doing. So I need to do 2.1 divided by 3. So how many 3's fit into 2? 0. I've run out of numbers, so I put the decimal point and I carry the 2. How many 3's fit into 21? 7. So I know 2.1 divided by 3 is 0.7. Then I do the standard form. Now, what do you do when you divide indices? Well, the law of division is that whatever this is, you subtract the powers, okay? So when you're dividing indices, you subtract the powers. So I'm going to need to do 10 to the power of 7, take minus 5. And when you're taking away a negative, you add them. So that would become 10 to the power of 12. So 0.7 times by 10 to the power of 12. I haven't finished yet though, because they have said, write your answer in standard form. So for it to be in standard form, it needs to be between 1 and 9.9 times by 10 to the power of something. So I need to times this by 7. Okay, so I've multiplied 0.7 by 10 in order to turn it into an integer so it can be in standard form. And because I'm timesing by 10, I then divide by a power of 10 on this side. So that will become 10 to the power of 11. Because each of these little powers, what does 10 to the power of 12 mean? It means 10 times 10 times 10, 12 times. So if I've times part of the calculation by 10, I need to divide the other part by 10 to keep it the same. So in standard form, that would be 7 times 10 to the power. Okay, so a changing the subject question. Now these questions, I cannot stress enough, just keep doing things until something makes sense, because all you need to do with a question like this is just move things from one side to the other, maybe factorize, and maybe do a couple of things. So step 1, whenever you have a fraction, you're generally going to want to multiply by the denominator. So I am going to multiply both sides by 4x plus 2. So I'd be left with y brackets 4x plus 2 equals 3 brackets 2x minus 8. And always bear in mind, it is x that you're trying to make the subject of the formula, so you want to end up with x equals. So what I could do is first, I could expand the brackets. So I'd be left with 4xy plus 2y equals 6x minus 24. Now, I've got x on both sides of the equation, and I've got x in terms that are not like terms. And if this happens, this is where it's a key sign that all we need to do is factorize. So let's bring the x terms onto one side, and then we can factorize. So if I first subtract 6x from both sides, I'd be left with 4xy, take 6x, plus 2y equals minus 24. And then I could just move the y. So I'd be left with 4xy minus 6x equals minus 24 minus 2y. And then I can factorize. So I want to factorize the x out so the x can be on its own. So that would be x on the outside, 4y take away 6 equals minus 24 minus 2y. And then the last final step would just be to say x equals minus 24 minus 2y over 4y take 6. It's not the nicest of fractions, but we have made x the subject of the formula. One little extra bit actually, this is quite ugly, and generally they're not going to want you to have like a negative numerator. So if you get a situation like this, I'll just show you why this works. So if, let's say, x was minus 8 over 2. What is my answer? Minus 8 divided by 2 is minus 4. Now, if I multiplied each part of the fraction by negative 1, I end up flipping it. So that would be 8 divided by minus 2. But that doesn't affect the end result because my end result is still minus 4. So what I can do in a situation like this is just times everything by minus 1. So x would be 24 plus 2y over, well, it would be negative 4y plus 6. So what I could then do is just rearrange it, 2y plus 24 over 6 minus 4y. It doesn't really matter which one comes first, but it's just nice to not have a negative at the beginning. So that is just one final little tip. Okay, so here is a circle theorem question. Now, once again, circle theorems are just about using the knowledge you know, thinking about all the things you know, all the circle theorems you know, and how you can apply them to this question. So we're told that A, B, C, D are points on the circumference of the circle, centre O. A, D, E, so ADE and BCE are straight lines. Okay, so that's good to know. And we want to work out the size of angle CDE. So this angle over here. Okay, so let's think about all of the things that we do know. Well, over here, you have the circle theorem of angles at the center are double those at circumference. So hopefully you saw that. So we could figure out what this here must be. Half of 132 is 66. So we know that this angle here must be 66. Okay. Next, we know over here, this is a quadrilateral. And because all 4 of its vertices are touching the circumference, it's a cyclic quadrilateral. And I know that opposite angles in a cyclic quadrilateral sum to 180 degrees. So therefore I could figure out what this angle here is. So 180 take away 66 is 114. So that's 114 degrees. Now this over here is a straight line. So you don't even need a circle theorem. You just need your basic geometric facts. You know that angles in a straight line sum to 180. So therefore 180 take away 114 is 66. And there's loads of ways you could have done this. This is just one of the ways. So that's 66 degrees over here. Now, over here, is this a triangle? Yep, I believe it is. And you know that angles in a triangle sum to 180. So therefore, and also I'm writing these because what does it say? Give a reason for each stage of your working. So it's great if you figure the answer out, but if you have not given your reason, then you cannot get the marks for reason. So this is why it's so important to know your angle facts and your circle theorems. So 180 take 66 take 16. 180 take 66 take 16 is 98. So over here I have got my angle CDE equals 98 degrees, and my reasoning is, I mean, if I were you, I would write the reasoning a little bit better. So angles at the center double those of circumference, therefore angle BAD equals 66, and do it that way. I should have done that really. So opposite angles in a cyclic quadrilateral sum to 180, therefore angle DCB equals 114, just to be on the safe side. Yeah. Okay, so in this question, I am being told that OAC is a sector of a circle, center O, radius 10 meters. Now with questions like this, it's super important to read the question and then just try and identify as much as you can from the diagram. So I know this is a radius. I know this is a sector of a circle because I've been told that. And if AO is a radius, it must be equal to OC because they're both radii of the same circle. So hopefully you identified that. If not, that's fine. But this is how we start to learn like what to identify. So I know I've got 2 radii, which ultimately means I would be able to form myself a little isosceles triangle if I needed to. I don't know if I do yet, but I'm just keeping my options open. Now, I'm then told that BA is a tangent to the circle at point A, and BC is a tangent to the circle at point C. And using circle theorems, what do I know about 2 tangents starting from the same point? So 2 tangents from the same point are equal in length. So therefore, I know that these two sides are equal, and then I know that I have a kite. So I know I'm dealing with a kite which has two pairs of equal sides, and I know that their right angles bisect at 90 degrees. Once again, I don't know if I need that information, but it's just getting every piece of information we can extract from the question. What else do I know? Well, if I start to label my diagram, I know that this is a tangent. I know that this is a radius, and this is what's it called? An area, a sector of a circle. So sector of a circle. So if you're like looking at this question, you're like, I don't know where to start, just think to yourself, do I know anything about a radius and a tangent meeting? And using circle theorems again, you know that a radius and a tangent meet at 90 degrees. Therefore, these angles here must be 90 degrees. Okay, so we've put some more information into the diagram. And if I know that all of these, so I know 3 of these angles now, and I know that I have a kite, which is a 4-sided shape. So therefore I know the angles in this kite are going to sum to 360. I can figure out what this angle here is. I would just need to do 360, take 180, because 2 lots of 90, take 120, which would leave me with 60 degrees. So I know that this angle here is 60. Ultimately, I'm trying to figure out the area of this shaded region. So in order to do that, I'm going to have to work out the total area of the kite. So total area of kite, and subtract this bit here. That's how we always do shaded regions. We do the total, take away the little bit of the area that you know. So take away the area, the sector. So the next thing I could do, just so that I have this to work with from later on, I could work out the area of the sector of the circle. How do you work out the area of a sector? Well, you imagine it's a full circle. So if it was a full circle, you would have done pi r squared, but it's a fraction of a circle. In this case, it's 120 over 360, which would simplify to 12 over 36, which would eventually simplify down to a third. So you might have spotted that, and you might know that you can just divide it by 3, or we can write it in its full form because this is a calculator paper, so it doesn't make much difference. Now, what's the length of the radius? It's 10, so that would be 100 pi times by 120 over 360, and that would give me the area of my sector. So I can just write that up over here for later. So area of sector is 100 pi divided by 3. Well, which, I mean, it doesn't cancel into something nice, so we can just leave that as 100 pi over 3. And that will come in handy later. Now what do I need to do? I need to somehow work out the area of the full kite. There's a few ways that we can do this, and with any question like this, there are so many different little routes that you can take. So it's just about following one step leading into the next step. So let's have a look at what I can do. Well, I know that in a kite, the diagonals intersect at right angles. So I could use that to form myself a right angle triangle over here, and then I can use trigonometry. So I know, do I know anything yet? No, I don't know anything. I just know that this length here is 60, this angle here and this angle here is going to be, oh, I haven't worked that out yet. Sorry, I'm rushing ahead. Okay, so now what do we need to do? We need to work out some lengths. So first of all, what we could do is work out something using the original circle that I've been given. So let's just draw that out. And by circle, I mean triangle. We know this angle here is 120, and we know this length here is 10, and this length here is 10 as well. So I could use my area of a triangle, or I could just use the sine rule. So if I labelled this angle C, this little side would be C. And if I labelled this A, this little angle here would be big A. So remember when I said that this forms an isosceles triangle? Really quickly, let's show you why the angles are going to be what they are. If this is 120 degrees, base angles in an isosceles triangle are equal. So 180 take 120 leaves you with 60. And there's two angles that are going to be equal. 60 divided by 2 is 30. So I know this angle here is 30. So how could I work out C? Well, A over sine A is equal to B over sine B is equal to C over sine C. That's just the sine rule. So let's just pick what to substitute in. So I know that 10 over sine 30 must be equal to C over sine 120. Remember, the sides are interchangeable. As long as the little letter is opposite the angle with the same corresponding big letter is fine. So therefore C is going to be 10 over sine 30 times by sine 120. So let's do that. 10 over sine 30 times by sine 120 gives me 10 root 3. Okay, so I know that this long line here is 10 root 3. So let's write that somewhere important too, so it doesn't get lost. AC is 10 root 3. Okay, if I know what the size of AC is, then I've lost where I was going. So I've got the area of the sector. I need to work out the area of the kite. I know this length here is 10 root 3. And I want to work out the area of the full kite. So I could work out what the length of AB or BC is. And once again, there are a few ways to do this. If this is 10 root 3, I could turn it into a right angled triangle. I know that but diagonals of a kite are perpendicular and they bisect it, so they form two equal triangles. So therefore, this length here would be 5 root 3. It would be half of the base. And this angle here would be half of 60, which is 30. Okay, so I'm trying to find AB, which is going to be C. I don't know the length of this yet, but I have an angle. So let's write out our trigonometry. You've got SOHCAHTOA. Which sides have you got? You've got the opposite and the hypotenuse. So I know that I'm going to use O and H. So sine theta is opposite over the hypotenuse. So sine 30 is 5 root 3 over the hypotenuse, which is C. So C sine 30 is 5 root 3, and therefore C is going to be 5 root 3 over sine 30, which is 5 root 3 over sine 30 is 10 root 3. Oh my gosh. And I've just seen a massive shortcut. So I could have done it that way. But I could have also realised that... okay. Over here, if I'd just worked out what its angles are, so that's 60 degrees, it's an isosceles triangle, therefore this is going to need to be 60, this is going to need to be 60. What do I know about equilateral triangle? Not isosceles, well, it is an isosceles triangle, but because the top angle is 60 degrees and the base two angles must be equal, it must be an equilateral triangle, therefore it has equal angles and equal sides. So I didn't need to do that bit, but some of you may not have spotted that, so it's fine, because for those that didn't spot it, we've worked it out. So now I have this length here, 10 root 3. I have this full length here, which is 10 root 3. I know that this length here is also going to be 10 root 3. So what I could do, and again, there's so many ways that you can do this, but the way I'm going to do it is choose to split the kite in half. So if I think about this as the triangle, I know that this length is 10 root 3. I know that this length is 10. And similarly here. So how do you work out the, and I know this angle here is 30. This is a right angle triangle. And this would be 60 degrees. How do you work out the area of a triangle? Because it's a right angle triangle, I can't use the half AB sine C. I'm just going to need to multiply the base times the height. And whenever we do triangles, remember it's the perpendicular height, the base that we multiply. So I'd just do 10 root 3 times by 10 divided by 2, which gives me 100 root 3 over 2. So the area of this would be 50 root 3, and they're identical. So the area of this would be 50 root 3 as well. So the total area of the kite, let's write this here, the total area of the kite is 100 root 3. How do I work out the area of the shaded region? I do area of kite, take area of sector. So I'm just going to do, where is it? Area of kite, 100 root 3, take away the area of the sector, 100 pi root over 3, and that gives me 100 root 3, take 100 pi over 3, which gives me 68.48532564. They've said correct to 3 significant figures, so you count 1, 2, third digit, look next door, it's more than 5, so you add 1 more. So that'd be 68.5 meters squared. Okay, it's probably, definitely 100% is a much more efficient way of doing it, but that's just one way. So hopefully that was helpful. Okay, so here we have got a bounds question with speed, distance and time. So it's helpful to just remember formula, speed is distance over time. So I know that Justine travelled 321 miles, correct to the nearest 5 miles. Okay, so 321 miles, 5 miles above would be 326, 5 miles below would be 316. So when I'm thinking of the highest possible value and the lowest possible value, it's always halfway. So that would be half of 5, which is 2.5. So 321 plus 2.5 is 323.5 is the maximum value that she could have travelled. And 321 take away 2.5 is 318.5. So that's the minimum distance that she possibly could have travelled. So upper bound of distance is 323.5 miles and lower bound of distance is 318.5 miles. Now, she travelled this in 265 minutes, correct to the nearest minute. So therefore, what are the minutes surrounding that? That's 266 and 264. So halfway between that, where could I put this? Upper bound of time is 265. Oh, wrote that wrong. 265.5 minutes. And the lower bound would be 264.5 minutes. So now I've worked out the upper bound and the lower bound of each of my things, I can look at the rest of the question. The speed limit on the road she travelled was 70 miles per hour. By considering bounds, work out if it's possible that she exceeded the speed limit. So if she exceeded it, then she needs to have been driving at the maximum speed, okay? And how do you get the maximum speed? So to get the, like, if this doesn't intuitively make sense to you, then just pick two random numbers. So let's say 10 and 2. And that would be the max and that would be the minimum. And think to yourself, I know that to work out speed, I need to do distance divided by time. So I need to figure out whether I'm using the upper bound or the lower bound. So let's say I use the upper bound. 10 divided by 2 is 5. 2 divided by 10 is 0.2. So I've realised that when I use the upper bound and then the lower bound, I end up with the maximum value. So what I'm going to do is I need to find the upper bound of her distance and divide that by the lower bound of her time, because the more you travel in the less amount of time, the higher your speed must be. So what's her upper bound of distance? Is 323.5 miles. Now the lower bound of time is 264.5 minutes. But whenever dealing with time, distance and speed, I always want to write that as a fraction of an hour. So what I'm going to do is write 264.5 divided by 60, which is 4.408. And I think that's 3 recurring. I wish it told you whether it's like actually recurring. Let's just say it is. So 4.4083 recurring hours. Okay, so let's do that. So 323.5 divided by answer equals 73.38374291. Is it possible that she exceeded the speed limit? Yes, it's possible. If she drove the max upper bound distance in the lower bound time, she exceeded it by over 3 miles per hour. A question that requires you to use the area of a triangle. Now the area of a triangle is half AB sine C. It is given to you on the formula sheet, but you need to know how to use it. So I'm told that the area of triangle ABC is 4√3 meters squared, and I need to find the value of x, which is located here. So let's think about what I can do. First things first, with advanced trigonometry, you want to label your triangle, and remember you can ignore the labels they have given you. So remember, the big letter relates to an angle and the little letters, so A and B, relate to sides. So I want C to be over here. That means this is going to be little c. It then doesn't matter which is A and B, so I'll just call this one A. So it's going to be big A, and this is B, and this will be little b. So now I've labelled it, I can substitute into my formula. I know that the area is 4√3, so I'm going to say 4√3 must equal a half times by A, which is this, x plus 2, times by B, which is this, 2x minus 3, times by sine C. And sine C, well, C, angle C is 60 degrees. So what can I do? Well, I can simplify first. So I know that, let's rearrange it so it's all of the things that I can divide by. X plus 2 brackets 2x minus 3. So this is the algebra over here. And this is the numbers. So what I can do is just divide both sides by a half times by sine 60. You can do it but step by step. So I could have done 4√3 divided by half and then divided by sine 60, or you could do it actually fine. Let's do it in step by step just so that I don't confuse anyone. So I'm timesing by a half. So step 1, I want to divide both sides by a half. So dividing by a half is the same as timesing by 2. but if you're not sure, still just enter it into your calculator, and you'd see that that becomes 8√3. So 8√3 equals sine 60 times by this. And then I'm just going to have to divide 8√3 by sine 60, which is 16. So essentially what you've done is, first of all, you have just substituted into the formula, and then what you're doing is you're trying to look for all of the values that are numerical and just move them to the other side of the equation. So you're just left with the algebra on one side and numbers on the other. So let's expand the brackets. So x times 2x would be 2x squared. X times minus 3 is minus 3x. 2 times 2x is 4x. And 2 times minus 3 is minus 6. So I know that 16 is 2x squared. Minus 3 plus 4 is 1 minus 6. Okay, so now I have a quadratic. And what do you do in order to solve a quadratic? In order to solve a quadratic, you need to get it, rearrange it so it's equal to 0. So we're going to subtract 16 from both sides. So I'd be left with 2x squared plus x, and then minus 6 minus 16 leaves me with minus 22 equals 0. And you could use the quadratic formula. So I'm just going to go ahead and use the quadratic formula. So with every quadratic, you know that it can be expressed in the form ax squared plus bx plus c. So therefore, with this equation, I know the value of a is 2, the value of b is 1, and the value of c is minus 22. So I'm just going to substitute that into the quadratic formula. So x is going to be minus 1 plus or minus the square root of 1 squared minus 4 times 2 times minus 22 over, and then 2 times a is 4. So I can simplify that. It would be 1 take away, and then 4 times 2 times negative 22 is 176. So that would be the next step. And then the final step is minus 1 plus or minus the square root of 177 over 4. So therefore my final answers are going to be x is minus 1 plus root 177 over 4. Or x is minus 1 minus 177 over 4. So these would be my two solutions, and let's see what they bring. So minus 1 plus 177 over 4 gives me 3.07633. And then if I just use the little arrows, oh, I deleted it, but you can just use the little arrows to change it, so you don't have to type the whole thing out again. But obviously don't worry if you do, because I just had to, because it deleted itself. So, or x is minus 3.57603. Now, because I'm dealing with a length, I know that it can't be negative, because you can't have a negative length. A length is like a thing that exists in the 3D world. It can't be negative. Like, you can go underwater with a length, but the length is still positive. So whenever you have any kind of length, this cannot be a possible solution. This is your only solution. And it says give your answer correct to 3 significant figures. So x is 3.08. Okay, so in this question, I've been given a shape and I've been asked to enlarge it by scale factor minus a third. Okay, so if you get a minus scale factor, it reverses the direction. Okay, so normally when we're doing enlargements, we have our center of enlargement, let's say it's here, and then we're like, how do I get from here to there? How do I get from my center of enlargement to the shape? And then you like enlarge it like that. But what we're doing when we reverse the direction is we start from the shape and go towards the center of enlargement and beyond. So we're essentially reversing the direction. So let's first plot our centre of enlargement, -1, -1 over here. And what I want to do is think to myself, okay, I've got 3 vertices, 3 corners of this shape. So let's start with this corner. What am I doing to get to the centre of enlargement? Well, I'm going from 2 to -1, so I'm going 3 down and 3 across. So what I'm going to do, because it's a third, you do whatever your distance is from your point, you multiply that by the scale factor. In this case, it's a third. 3 times a third is 1. So I'm going to go down and across 1 and plot that point there. That's x. Then I'll do it with another x in a different colour. So what do? I go 3 down and 6 across. So I'm going to have to go 1 down, and 6 divided by 2 is 2 across. So that would be where my other point is. And this point here, from 8 to -1, is 9. So I go 9 down and 3 across. A third of 9 is 3. So I'm going to go 3 down and 1 across. And then I just join my points together. And it says label your image B, so just give it a little B. Okay, but the key thing is the scale factor tells you how much larger the shape is or smaller. And the centre of enlargement is, if it's a negative, you start from the shape and you go to the centre of enlargement. If it's a positive, you start from the centre of enlargement and you go towards your shape. Okay, so in this question, I am being shown a graph which shows the volume of water in a container. And I'm being asked to calculate an estimate for the gradient of the graph when t is 17.5. So whenever you are estimating a gradient, and the reason you would do this is because you don't have a straight line, you have a graph that has a curve. Whenever you are estimating a gradient, what you want to do is use a tangent to the curve. So the first thing you do is you go to 17.5. So that's this point over here, okay? And you draw a straight line. A tangent is just a straight line that touches the curve at one point. You draw a straight line. It's so hard to do it on here. So you draw a straight line and you're going to calculate the gradient of that. So now that we've got a straight line, we can calculate the gradient like we normally did. So how do you work out gradient? The gradient is the change in the y coordinates over the change in the x coordinates. So let's draw myself a little triangle, and you're always trying to look for a part where the line goes exactly through a diagonal. This isn't amazing because my line is so thick, so it covers the line, but we do what we can. So I'm going to just get rid of that line actually to see where it would touch. So if I've drawn the straight line, oops, didn't mean to do that. So if I've drawn that straight line like that, then it would probably be touching about here. Okay, so if I've got a straight line, why is this so difficult? You have got a ruler and a piece of paper, so yours is going to be a lot better. But I'm just showing you the method. My answer might be slightly out of range. So just work out the gradient of your line. So if that was the top of the line, let's first figure out what the scale is. So that's 12.5. So each little square must be 0.5 because the distance between 12.5 and 10 is 2.5, and 2.5 divided by 5 is 0.5. So that must mean that this would be 12.5, 13, 13.5. This coordinate here is 10. So the distance for my y is going to be 3.5. And then let's look at the distance for my x values. So my x value is 20. And then over here, that value would be, well, this would be 17.5. So that value would be 17. Okay, so the distance of my x values is 3. So then the gradient is going to be 3.5 divided by 3, which gives me 1.16. And that is in range, luckily. Yours is going to be a lot more accurate as long as you've drawn a tangent. Okay, so the key thing is that you must draw a tangent to the curve and try and make it as nice and straight as possible. Use a thin pencil so that it doesn't cover up the squares like mine does. And then you just work out the gradient of this line. Okay, and any answer in the range of 0.9 to 1.2 will be absolutely fine. Okay, so here I'm now being asked to describe fully what the gradient in part A represents. So I've just drawn a little sketch of the graph. So gradient in general represents the rate of change. So put into the context of this graph, the gradient of this graph represents the rate of change of the volume. Okay, so essentially how much water is being added at what rate into the container. So gradient is generally representative of the rate of change, and then you just put it into context of the. Okay, so here I have a graph transformation. I am given the graph of y equals f of x, and I am asked to sketch the graph of y equals f of negative x. So because I have a negative sign inside the brackets next to the x, what that means is that all of the x coordinates are going to be flipped. It's going to be the negative version of them. So let's have a look at my x coordinates. So I've got one over here. This graph has no scale, so let's just quickly give it a scale just so that we can see what we're doing, and we do an equal amount on each side. So that would be -5, so I could flip it to +5 would be my first coordinate. Then my next coordinate is over here, -3, so it'll be here at +3. The y coordinates are not changing. The only transformation that is occurring is that the x coordinates are being flipped. Then you've got another x coordinate over here at 1. Then you've got your final one here and next one here. So I'm just going to remove all of the original x coordinates and join up my line. So straight over here, up. And I should have plotted that there. I don't know why I didn't. It's 5, 0 because the y coordinates don't change. So all you're seeing essentially is a reflection in the y-axis. So here I've got a trigonometric graph transformation. I am told that here is a sketch of the graph y equals tan x. So the first thing that I could do is just think to myself, okay, what do I know about the graph y equals tan x? Hopefully you know how to sketch it. So you know it goes from -90 to 90 and then it repeats. So the next part would be 270 and so on. So just having that in the back of my mind can help me. Now let's read the next part. So it says the graph of y equals tan x is translated. So moved, it just means it's going to be moved up or down the x-axis and the y-axis to give the graph y equals g of x. And following the translation, the point Q shown on the graph above moves to point R, which has the coordinates 90, -5. So if I label my graph first of all, I know this is going to be -90, this will be 90, this will be 270. And therefore, point Q is going to, like each little part here, that would be 180. That's a distance of 90, so that part here must be 360. So therefore, the coordinate of Q would be 360, 0. And I know that the point Q is moved to create the coordinate R, which is 90, -5. So essentially, the graph is kind of, oh, that's really poor sketch, been translated like this. Okay, so what have I done in order to get that? Well, let's look at what happens in the x-axis first. I've moved from 270 to 90. So all of my x-coordinates are shifted over by 270. So therefore, over here, I've got the graph y equals tan x. And what I can do is just say tan x plus 270. Now the reason I do that is because anything I put inside the bracket is actually the opposite of what's happening. So because I'm saying add 270, what I'm actually doing is all the x coordinates are subtracting from 270. So whatever goes into the bracket, inside the bracket, you do the opposite. And then what am I doing with my y? Well, I go from 0 to -5. So I'm just shifting it downwards by 5. So I'd say y equals tan x plus 270 and then take 5. So find an expression for g of x in terms of x. You'd say g of x equals tan bracket x plus 270 take 5. Question, I've been given the equation of a curve, which is y equals 4x squared minus 56x, and I'm told that this curve has one turning point. Now a turning point on a quadratic is literally, as it says, the point at which the equation or the graph turns. So you could think about it as the line of symmetry. So the turning point would be over here. That would be a minimum point. You also have a maximum point when the equation is a minus x squared. But right now we're just looking for this turning point. And we can do something with a quadratic, which is we can complete the square, and anything that is in its completed square form would look something like this, where x plus a minus b. So you should be familiar with completing the square. If not, watch the video on completing the square and get up to scratch on that. So completing the square allows me to find the turning point of my graph. Now the turning point is always going to be the inverse of whatever is in the bracket. So the x coordinate is going to be the inverse of this, and it's always going to be whatever the y-intercept is. So over here, that would be, in this case, minus b. If it was a plus b, it would be plus b. But this will make a lot more sense once we've actually completed the square and we can show it. But this is the completed the square form. And in order to find the turning point, all I'm doing is I'm going to write my x coordinate is going to be the inverse of whatever this value is. So if we had, for example, x plus 6 minus 20, the turning point would be minus 6 minus 20. So the x coordinate is always the inverse of here and the y coordinate remains the same. So that's something to bear in mind for later. Now, first of all, what we want to do is start by completing the square. So when I'm completing the square, it just makes your life so much easier if you only deal with x squared. So in this equation, I've been given 4x squared minus 56x. So the first thing I could do is divide by 4 to just make my life a lot easier. So I take 4 out, and then that would become x squared minus 14x. And then I just have to worry about completing the square of this part here. So when I'm completing the square, what does that mean? It means I'm looking for an expression of a perfect square. Now, what do I mean by a perfect square? So a perfect square is something like this, where it's something multiplied by itself. So x plus 3 squared. What happens when I actually physically do that? I get x plus 3, and then I'd end up with x squared plus 6x plus 9. Okay, so the reason I'm using a perfect square is because it's going to give me the first part of my expression. And in order to complete the square, what I do is I halve the coefficient of x. Okay, so the coefficient of just x, I'd write it as x minus 7 squared. Okay, so that's the first part, the first thing that I do. Some working that you might want to do just to the side, just so that you can see, is actually expand it and say, what happens when I do x minus 7 squared? Well, that would give me x squared minus 7x plus 49. So simplify that, that would give me x squared minus 14x plus 49. So as you can see, I get the first part. This and that are equal, which is what this expression gives me. However, I also have an added on bit of plus 49. So when I complete the square, I just think to myself, what do I need to add or subtract in order to knock that off? Well, 49 take 49 is going to get me back to 0. The reason I do this is because this over here is technically x squared take 14x plus 49. So that's why I subtract the 49 to get me back to 0. So I have completed the square of this equation but don't forget that I factorised it. So what I can then do is expand the brackets up again. So that would become 4 lots of x minus 7 squared, and then 4 times by negative 49 is minus 196. Now remember that the turning points, it's going to be the inverse of whatever is in the bracket. You're trying to get the bracket to become 0. So 7 takes 7 gives me 0. So therefore the x coordinate is going to be 7 and the y coordinate is minus 196. But all you need to do for this question is complete the square, because by completing the square, you show that they are. Okay, so here I've got some nice algebraic fractions. Now what's the key with algebraic fractions? Remember to add or subtract fractions. They need to have the same denominator. So the first thing that I want to do whenever I'm dealing with algebraic fractions is think to myself, okay, how can I make the denominator common? So let's just deal with this part first. We can deal with the negative 3 later. So we've got 2x plus 3 over x minus 5 plus x take 4 over x plus 5. Now, in order to do algebraic fractions, generally you're just going to bring together your denominators, and your common denominator is going to be the product of the two denominators. So your new denominator would be x minus 5, x plus 5, because you're just bringing them together, just like if you had 2 over 4 plus 3 over 6, you could turn this into 4 times 6, which is 24, as a common denominator. It's not the lowest common multiple, that would be 12, but because we're dealing with algebra, it doesn't matter. So my denominator is just going to be the product of the two denominators. And then I need to think to myself, what have I done to each fraction in order to turn it into this denominator? Well, just like over here, what I would have said is I've multiplied 4 by 6 in order to get that as my denominator. Over here, I've multiplied the denominator by x plus 5. So I need to do the same to my numerator, just like I would have done here to keep the fraction in proportion. So this would become 2x plus 3 brackets x plus 5. So I'll actually highlight it in a different colour so that you can see that's what you're multiplying by. And then if we think about this bracket here, what have I multiplied by? Well, I've multiplied the denominator by x minus 5. So I'm going to have to do that to my numerator as well. Okay, so now I've got a common denominator and some numerators that I can expand. So let's do it bit by bit. What I can do first of all is multiply my denominator. So x take 5 multiplied by x plus 5, x times x is x squared, plus 5x minus 5x, and then minus 25. So if I simplified that, that would give me x squared minus 25 is my denominator. And then I'm going to multiply my numerators. So I've got 2x plus 3 multiplied by x plus 5, which would become 2x squared plus 10x plus 3x plus 15. So bring it together, that becomes 2x squared plus 13x plus 15. And now let's multiply the last numerator. So I've got x take 4 multiplied by x take 5. That would become x squared minus 5x minus 4x. And then don't be fooled, don't forget about the signs, plus 20. So minus 5 minus 4 is minus 9x, and then you add 20. So we can write that all on top as one long numerator because both my fractions have the same denominator. So that would give me x squared minus 9x plus 20. Now what I need to do is I've got a nice long numerator and I'm going to want to simplify that. So I've got 2x squared plus x squared. So that would become 3x squared. I've got 13x take 9x. So 13 take away 9 is going to give me positive 4. And then I've got 15 plus 20. So that will be plus 35 over x squared minus 25. So now I've dealt with the fractions, but I'm still left with, I need to subtract 3. So what do I do in order to add or subtract fractions? I know that they need to have the same denominator. So what I'm going to have to do, now that I've cleaned up the first part of the calculation, I'm going to have to ensure that 3 has a denominator of, or minus 3, has a denominator of x squared minus 25 in order to be able to add or subtract them. So if the denominator, if I've times 3 over 1 by x squared to take 25 to give it this denominator, I'm going to have to times the numerator by x squared minus 25 as well. Whatever you do to the numerator, you have to do to the denominator to keep it in the same proportion. So that would give me 3x squared minus 25. And obviously, if we just cancelled those out, so if we did this divided by this, that leaves me with 3. Okay, as long as the top, whatever's on the top, divides by whatever's on the bottom when it's a product, then it cancels to make 1. So let's expand this and bring it all into one fraction. I've got 3x squared plus 4x plus 35, and then take 3x squared, and then negative 3 times by negative 25 is going to give me positive 75. And all of this is over x squared minus 25. So now the last part is just simplify. Well, 3x squared, take 3x squared, is going to cancel out. I'm going to be left with 4x, and then 35 plus 75 is 110. So I'm left with this fraction, which is the form that they told me that they wanted it in. And I need to work out the value of a, which is 4, and the value of b. Okay, so in this question, I'm dealing with bounds. Now, I've been told that a race is measured to have a distance of 10.6 kilometers, correct to the nearest 0.1 kilometers. And that Sam runs the race in a time of 31 minutes 48 seconds, correct to the nearest second. So what I want to do first of all is calculate my upper and lower bound. So I know that the race is 10.6 kilometers when it's been rounded to the nearest 0.1 kilometers. So what does that mean? Well, 0.1 kilometers means it's one decimal place that I've rounded to. So let's think about what the 0.1 kilometers surrounding 10.6 would be, or what the decimal places surrounding that would be. So that would be 10.7 or 10.5. Now, to work out your upper bound, you're going to work out the maximum possible value it could be before it would have rounded up to 10.7. And for the lower bound, it's the maximum possible value, or the minimum possible value it could be before it's rounded down to 10.5. So we'd say that this would be 10.65 and 10.55. And a lot of people get confused by this because obviously if it was 10.65 to one decimal place, it would round to 10.7, but technically it would be 10.649 recurring. That's a little bit complicated to use. So for GCSE for bounds, we just say it's 10.65 as the upper bound. And generally, if it would be an error interval, we would say it like this. So we know not to actually include 10.65, but we use it as our bound. So if I write my bounds up here, I know that for the distance, the upper bound is going to be 10.65 kilometers, and the lower bound is going to be 10.55 kilometers. Now I want to do the same thing for time. So I know that Sam runs the race in 31 minutes 48 seconds. So let's just round the 48 seconds bit and then we'll add it onto the minutes. So 48 seconds, what are the seconds surrounding that? That would be 49 and 47. So what would the maximum upper bound be? That would be 48.5, and 47.5 would be my lower bound. So in terms of time, the upper bound is going to be 31 minutes and 48.5 seconds, and the lower bound is going to be 31 minutes and 47.5 seconds. Now, generally when we're working with time, we want to write it as in terms of an hour, because speed is generally calculated in kilometers or miles per hour. So what we're going to need to do is convert my time into hours. So let's think about how we can do this. Well, first of all, I'm going to need to convert 9 minutes and seconds into a constant unit. So I could convert the minutes into seconds. So 31, remember, I'm sure you know this, but just for reference, 1 minute is 60 seconds. So 31 times by 60 is 1,860. And then if I add 48.5 to it, that gives me 1,908.5. So my upper bound is actually 1,908.5 seconds. And let's do the same for my lower bound, which is 47.5 seconds. So 31 times by 60 plus 47.5 gives me 1,907.5 seconds. This still isn't in terms of an hour. So how do I convert seconds to hours? So this is quite simple stuff, but people just get confused on this so frequently. So I'm just going to explain. So there are 60 seconds in a minute and 60 minutes in an hour. So therefore, to go from seconds to a minute, we're going to divide by 60. And to go from minutes to an hour, we divide by 60 again. So in total, I'm going to be dividing by 3,600. And that is because 1 hour is made up of 3,600 seconds. Okay, so let's calculate the new lower bound in terms of hours. I'm going to do 1,908.5 divided by 3,600 and 1,907.5 divided by 3,600. So 3,600, my lower bound would be 0.52986111, and my upper bound would be 1,908.5 divided by 3,600 gives me 0.5301388889. Okay, so what I want to do now is actually calculate what the speed must be. So if you're not 100% confident with bounds, then the best thing to do would just be to calculate all the possibilities. So all of the possibilities would be the upper bound of distance divided by the upper bound of time, the upper bound of distance divided by the lower bound of time, the lower bound of distance divided by the upper bound of time, and the lower bound of distance divided by the lower bound of time. So let's just plug those values in. That would be 10.65 and then 10.55. I'm just writing out the distance first. Over the upper bound is 0.53, the lower bound is 0.529, the upper bound is 0.53, and the lower bound is 0.529. So now I know the calculations that I need to do, and I'm going to get 4 values, which I'll write here. So this is my first calculation, second calculation, third, and fourth. So 10.65 divided by 0.5301388 is 20.089075553. Do the same thing again. So 10.65 divided by 0.5298611 is 20.0996066. Then I do 10.55 divided by 0.530138 gives me 19.9004, and then 10.55 divided by 0.5298611 gives me 19.91087.815. So now you've got all 4 possibilities, and you need to calculate the value of v to a suitable degree of accuracy. So what value would satisfy all 4 of these options? Well, if I think about rounding to, so 20.089, and then let's just pick 19.91. What would a suitable degree of accuracy be to ensure that both of my values, well, all 4, round to the same thing? In this case, we would probably round to 2 significant figures, because if you rounded to 1 decimal place, what would that be? That would be 20.1, and this would be 19.9. So the figures don't match. So if I rounded to the nearest ones, so to 2 significant figures, this would round to 20, so would this. This would round to 20, this would round to 20, this would round to 20, this would round to 20. Okay, so by considering bounds, I would say v equals 20. Okay, and in this last question, I am shown a geometric sequence. Now, all a geometric sequence is, so if we start with a really basic one, so 4, 16, 64, what's happening each time? Instead of adding or subtracting, I am multiplying to get to the next term. So how do I get from 4 to 16? I multiply by 4. 16 to 64, I multiply by 4. So to get to the next term, I'm multiplying by 4. So in a geometric sequence, your next term is going to be found by multiplying by n. Okay, so multiplying by a value, by a scale factor. So I know that the first 3 terms of this geometric sequence are root x minus 1, 1, and then root x plus 1. I am not told anything else apart from that these are the first 3 terms, and I need to find the value of x. Okay, so the value of x is going to be something in the terms. What I'm first probably going to need to do is think to myself, okay, what is the value of n? Okay, so root x, take 1, multiplied by n equals 1. And similarly, 1 multiplied by n is root x plus 1, because all I'm doing is I'm, to get from one term to the next, I'm multiplying by n. So what I want to do is figure out what my multiplier is. How can I do that? Well, if you ever get confused with something algebraic or something that you're like, how does this work? Just take it back to the basics. So with a basic geometric sequence where you had 4, 16, 64, how could you figure out what n is? Well, if you do the third term, let's say 64 divided by 16, what happens? 64 divided by 16 is 4. Okay, so if you divide, like the second term divided by the first term, or the third term divided by the second term, you get your scale factor, just like when you do enlargements. So I know that in this case, n is 4. So if I apply the same rules, and just to double check that this is true, let's try it again. 16 divided by 4 is 4. Okay, so if you're going this way, and you divide, let's say, third term over second term, or second term over first term, that is going to give you your value of n. So let's do the same for our geometric sequence. So this is the third term, this is the second term, and this is the first term. So I could either write my scale factor as 1 over root x minus 1, or I could write it as root x plus 1 over 1. Okay, they are going to be equivalent because they both equal n. So n equals this and n equals this, and they have to be the same thing because in a geometric sequence you're multiplying by the same number each time. So if they are equal, what can I do? Well, when anything's equal, I can just put a big equal sign next to it and solve. So I know, and let's actually get rid of this sequence too. So, oh no, I just deleted it. Okay, so I know that 1 over root x minus 1 must be equal to root x plus 1 over 1. Okay, I've got just an algebraic equation. All I need to do is rearrange it and solve to find x. So what can I do first? Well, divided by 1 doesn't really do anything. So I could multiply both sides by this denominator here. So multiply by root x, take 1. So I'd be left with 1 equals root x plus 1, which is already there, multiplied by root x minus 1. What can I then do? Expand and simplify. So remember, a root of anything multiplied by a root of anything is just itself. With a common example, what's the square root of 25 times the square root of 25? Well, I know that's 5 times 5, which is 25. And so therefore, anytime you multiply a third by itself, it's like it's unthird itself. So root x times root x is going to be x. Root x times -1, it will be negative root x. 1 times root x is going to be positive root x. And 1 times -1 is going to be -1. So I'd be left with 1 equals x minus root x plus root x would cancel, minus 1. So therefore, if I add 1 to both sides, x equals 2. And there we go. We found the value of x and we know that it is 2. Okay, so finally, I'm being asked to show that the fifth term of the sequence is 7 plus 5 root 2. Now, the third term of the sequence was root x plus 1. So third term is root x plus 1. I know that the multiplier of my geometric sequence is x plus 1. And I've also, root x plus 1, and I've also, from the previous question, figured out that the value of x is 2. So what could I do? I could substitute the value of x into my equation. So that would be root 2 plus 1. So I know that my multiplier now is root 2 plus 1. How do you get to the fourth term and the fifth term? Well, what I'm going to need to do is multiply this, root x plus 1, by my multiplier. So that would be root 2 plus 1. So I can expand the brackets. Also, actually, sorry, we could do something else. I actually know what the third term is. I know that the third term is going to be root 2 plus 1. So I can just do that. So I know the third term is root 2 plus 1. My multiplier is root 2 plus 1. Remember, all I've done to work out that the third term is root 2 plus 1 is from the previous question I figured out that x is 2. And I'm multiplying by the scale factor. Remember, geometric sequences, whatever you multiply by, you figure it out by doing the next term divided by the previous term. So root 2 times root 2 is 2. Root 2 times 1 is root 2. 1 times root 2 is root 2, and that's 1. So that would give me 2 plus 2 root 2 plus 1, which is 3 plus 2 root 2. So that's the fourth term. So what am I going to do next? To work out the fifth term, I'm going to have to do 3 plus 2 root 2 multiplied by my scale factor of enlargement, which is root 2 plus 1. So 3 times root 2 leaves me with 3 root 2. 3 times by 1 is 3. 2 root 2 times by root 2. So remember, when we're doing thirds, we could write it like this. And anything times by itself is itself. So that would become 4. And then 2 root 2 plus 1 times 1 is just 2 root 2. So if I simplify that, 3 root 2 plus 2 root 2 is 5 root 2. And 3 plus 4 is 7. So that's how you show that. Now you could also have just multiplied algebraically and then only substituted x in at the very end. You can do this whichever way you want to, but hopefully that helps make the geometric sequences part a little bit less confusing. The key thing is just think back to basics. Think of a basic geometric sequence. You could even think of like the 2 times tables, or like multiplying by 2, so 2, 4, 8. And think, what do you do to get from one term to the next? I times this by 2, I times this by 2. What's my scale factor of enlargement? Well, 8 divided by 4 is 2. So what did I do? I divided the third term by the second to find that. So yes, any questions, let me know. But hopefully that makes sense. And thank you for watching. Okay, so in this question, I'm shown the graph y equals f of x, and I'm asked to sketch the graph of y equals f of x plus 2. Now remember that when you've got a transformation occurring within the bracket, so something is inside the bracket, we always do the inverse. So when x is being affected inside the bracket, we do the inverse. So that means we're moving along the x-axis minus 2. So each x coordinate is going to be shifted 2 to the left. So let's have a look at what's happening here. So let's start with this x coordinate. I'm going to shift it 2 to the left. So that would become minus 3. Then let's look at this x coordinate. So it's 0. So I'm going to shift it 2 to the left. So that would be minus 2. Then let's look at this coordinate, shift it 2 to the left over here. And then this coordinate over here would become 0. And we can do this strange one. So that is about 2 2/3. So 2 2/3 take away 2 is going to be just 2/3. So that will be up here. And this coordinate here, let's say it's roughly minus 1.5. So that would be roughly minus 3.5. Okay, and now we just join the curve up. So join it as accurately as we can. And here you've got your graph transformation. So the key thing is that when you've got something inside the bracket, you always do the inverse. So if it was negative 2, you'd be adding 2. So in this next part of the question, I have graph A, which is over here, the strange little graph. And this has been reflected to give graph B. So where would this have been reflected? Well, if I look at the line of reflection, that would be the x-axis. So when y equals 0. The equation of the graph A is y equals g of x. And I need to write down an equation of graph B. So let's have a look at what has been affected. Now in each of these reflections, my x coordinates, so if that one here is a mirror image of this one here, my x coordinates remain the same. So x coordinates remain the same. So therefore I know that I'm not going to be affecting anything inside the bracket. I'm only affecting the y coordinates, and when the y coordinates are affected, that's dealing with things outside of the bracket. So what's happening to all of my y coordinates? Well, let's just pick this coordinate here on my original graph. That would be negative 2, 2, and then its mirror image is over here, which is negative 2, negative 2. So what's happened to my y coordinate? Well, it's been inversed. So it was originally positive, and now it's negative. Let's try another one. Over here, that would be 0.52, and then over here is 0.5, negative 2. So the equation of the graph is going to be y equals minus g of x, okay, because the graph has been reflected and all of the y coordinates are now their negative versions. Okay, so here I've got a vectors question. I'm told that A, B, C, P is a parallelogram, which means that all of its sides are going to be equal. So all vectors that are parallel are also going to be equal. So let's just fill that in. K is the point on AC, such that A to K and K to C is 1 to 3. Okay, and L is the point on AB such that AL is a third of AB. Okay, so let's start by working out, okay, we'll find an expression for PK in terms of A and B. So PK would be here. So how can I get from PK? Well, there's a few ways. I could either go along here and then down there, or I could go along here and up here. So in order to find PK, I'm going to need to first work out what AC must be. So how do I get from A to C? Well, I start from here, so I'm going to do 4A, and then I know this vector is 5B, so that would be 4A plus 5B. Now, AK is going to be a quarter of whatever AC is, so that's going to be a quarter 4A plus 5B. So then a quarter times by 4 is A, and then a quarter times by 5 is going to be 5 over 4B. So I know that AK is A plus 5/4 B. So therefore, PK is going to be, we're going down, so it's going to be negative 4A plus whatever AK was, which is A plus 5 over 4B, minus 4A plus A is minus 3A plus 5 over 4B. Next, I need to prove that PKL is a straight line. So how do you prove that something is a straight line? Well, in order to prove that it's a straight line, you need to show that two vectors are parallel. And in order to show that they are parallel, you need to show that they are multiples of one another. And they also need to go through the same point. So let's think about the line PKL. It's over here. What vectors is that made up of? It's made up of PK plus KL. So I know that the vector PK is minus 3A plus 5 over 4B. So if I can find out what the vector KL is and show that it's a multiple, then it's two vectors that are parallel and they go through the same point, which is K. So let's have a think about how I could work out what KL is. So how do I get from K to L? Well, I would do this root plus this root. So the inverse of AK, oh no, I've lost where AK was. Damn it. Okay, let's work it out again. So AK is a quarter of, what did I say AC was? 4A plus 5B. So that would be A plus 5 over 4B. Okay, so KL is going to be the inverse of this because I'm going in the opposite direction. So it's going to be minus A minus 5 over 4B. And then plus whatever AL is. So what is AL? Well, I know that L is on the point AB such that AL is a third of AB. And if AB is 5B, then AL is going to be 5 over 3B. So that's quite a nice one actually. So KL is going to be minus A plus 5 over 4B plus 5 over 3B. So let's simplify that. So you could just do your fractional things here. So 5 quarters plus 5 thirds. In order to add or subtract, they need to be the same denominator. So the lowest common multiple of 4 and 3 is 12. So 4 times 3 makes 12, 5 times 3 is 15, 3 times 4 makes 12, so 5 times 4 is 20. So I'd be left with minus A plus 35 over 4B. Is this correct? K to A would be minus, oh, nope. This is what I did wrong. This should be a minus. So therefore minus 5 quarters, okay. So therefore it would be 20 over 12 minus 15 over 12, which would be 5 over 12. That makes a lot more sense. Plus 5 over 12b. Okay. Okay, so I just rubbed everything out so that there's a little bit more space. So I know that KL is minus A plus 5/12b. I know that PK is minus 3A plus 5 over 4b. So I need to prove that they are multiples of each other. Well, PK is 3 lots of KL. How can you prove that? If KL is minus a plus 5/12 b. If you multiplied it by 3, that would become minus 3a, and 5/12 times by 3 gives you 15/12, which if you simplified it, divide it by 3, is 5/4. Okay, so KL times by 3 would give you this. So therefore, we can say that PK is a multiple of KL. Therefore, they are parallel, and both vectors go through the same point K. Therefore, they are on a straight line. And we have a vector question. We've been given a quadrilateral. I'm told that FE, the vector FE is A, ED is B, and CD is 2A. And I'm told that the point P is such that CEP is a straight line and that CE equals EP. So let's just visualize what that looks like. So CEP, it's not super straight, but hey, what can you do? So whatever CE is, it's equal to EP. And I need to use a vector method to prove that CF, so this line here, is parallel to DP. Obviously, this is not drawn to scale, which is why they don't look parallel. Now, the key thing is to remember that parallel vectors are multiples of one another. So in order to prove that something is parallel, you need to prove that show that it's a multiple of the other thing. So for instance, if vector A was 2a plus 3b and vector B was 4a plus 6b, you could factorize that to say that's 2 lots of 2a plus 3b, and therefore B is 2 lots of A. So that's how we prove that the vectors are parallel. So that's what we're looking for. So let's have a look at what's going on here and which vectors I can write as what. So first of all, let's have a look at how I can write CE. So the vector CE, remember with the vectors, all we're doing is we're like a little ladybug, and all we can do is travel along the vector lines that we've already been told. So I've been told to get from CE, I'm going to go along this route. So that's going to be 2a. I'm going to have to go down this way. Now this vector going in this direction is B. And because I'm going in the inverse direction, it's going to be negative B. So I'm going to write negative B. And that's how I get to CE. So if I know that CE is 2a minus B, then EP must also be 2a minus B because I know that they are the same. Now I need to figure out what DP is. So let's just get rid of these lines here. So how can I get from D to P? Well, I can go along here, which is negative B, and then along here, and I figured out that I know that EP is 2a minus B. So let's simplify that. That gives me 2a minus 2b. Now let's have a look at the vector CF, because I'm trying to look at the vector CF and DP. So I've got DP over here. I know DP can be written as 2a minus 2b. And now I just need to figure out how I can write the vector CF. So once again, let's follow the lines. How can I get from C to F? So I start from C, I go along. So I start with 2a plus, and then negative B because I'm going in the inverse direction to the direction of the arrow. And then I go negative A as well because it's in the opposite direction of the arrow. So let's simplify that. 2a take away A leaves me with A, and plus negative B is minus B. So how can I write that? Well, CF equals A minus B, and DP equals 2a minus 2b. Now, in order to show that they are parallel, I need to show that they are multiples of one another. So what I can do is factorize this to make it 2a minus b. Once you said, so I know that dp is 2 lots of the vector cf, so I could say dp is 2 lots of the vector cf, therefore they are parallel. And in the last question, I have been given a regular heptagon. Now a heptagon is just a 7-sided shape, and the fact that it is regular is really important because any shape that is regular, any regular polygon, has all equal sides and all equal angles. So I know that this side is equal to this side, 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 and so forth. And I know that each of the angles are going to be exactly the same. So therefore, if I know what the sum of the angles are, I just divide by 7. Now, using the rules of polygons, so you might have done this before when you're looking at any sized polygon, to work out what the interior angles is, you use the rule n take 2 times by 180. And what this means is, let's say you start from any vertice, you join it up to the next vertice, and then the next one, and the next one, and the next one, and the next one, and the next one. That one's a bit wonky. So why have I done this? It's to see how many triangles fit into this polygon. So that's 1, 2, 3, 4, 5. And why do I do this? Because in each triangle, I know the angles add to 180 degrees. So if you try this with absolutely any polygon, you will find that there's always 2 less triangles than there are number of sides. That's why I do the number of sides take away 2 times by 180. So that's just a little recap on that. So I know that there are 5 triangles in this shape, and 5 times 180 gives me, 5 times 180 is 900. So I know that the sum of the interior angles, so this angle plus this angle plus this angle and so forth, they are all going to add to make 900 degrees. Now I know that there are 7 equal angles, so I'm going to do 900 divided by 7 to figure out what one of these angles is. And that would be 128.5714. Okay, so I know that each little angle is going to be 128.5714. Okay, so I've just worked out the size of the angles because it's a regular heptagon, and that's the information that's been given to me, and that's going to be helpful. Now, I am being asked to calculate the length of GB, which is this length here. And I'm also told that the area of this triangle is 30 centimeters squared. So if I just draw this triangle over here, I know that it's going to be an isosceles triangle because I know that it's a regular heptagon. So this side GA is going to be equal to this side here. I know that this angle here is 128.5714. And I know that its total area is 30 centimeters squared. Now, using your trigonometry, the area of a triangle is half AB sine C. Okay, so that's a formula that we use to work out the area of a triangle if it's not a right angle triangle, or if it's not one that I know the perpendicular height of. I label my triangles. So sine C, remember the big letters, they represent an angle, and the little letters, they represent a side. So I've been given the big sine C, so this is going to be C, and this and that side are going to be A and B. Now I know that they're actually going to be the same side, so I can just actually call them X and X just to make my life easier. And I can substitute. So I know the area is 30 centimeters squared. So I'd say 30 equals a half times by X, because this is these two sides, A and B, times by sine 128.5714. So then I could just simplify this. So that would become 30 equals x squared times by sine 128.5714 divided by 2, because remember, timesing by a half is the same as dividing by 2. You don't have to simplify it like this, you can just start rearranging it immediately. But then if I times both sides by 2, because I'm just trying to rearrange it now to solve x, so 60 is going to equal x squared times by sine 128.5714. And in order to get x squared, I'm going to just need to divide both sides by sine 128. So x squared is going to be 60 divided by sine 128.5714. And what does that give me? 60 divided by sine. Answer gives me 76.74288046. And the last final part is the square root of x. So that gives me 8.76030139. Okay, so now I know the length of the sides. So each of these sides are 8.76. And I'm trying to work out the length of GB. So once again, I'm going to use maybe the sine rule, maybe the cosine rule. Let's have a look at the information that I've been given. Okay, so I've got our triangle. I now know a little bit more information. So if I use the cosine rule, which is a squared equals b squared plus c squared minus 2bc cos a, I can figure out what the length of GB would be. So a squared and cos a are going to be opposite each other. Remember, you can label your triangle however you want. So if this is the big A, this is going to be little a, and this are going to be B and C. It doesn't matter which one's which. So a squared is going to be 8.76 squared plus 8.76 squared. Take away 2 times 8.76 times 8.76 times by cos 128.571. So let's just clean that up. 8.76 squared plus 8.76 squared gives me 153.4752, and I'm going to subtract 8.76 times by 8.76 times by cos 128.571, which gives me minus, did I do times 2? Sorry, I don't know what I did. Nope, times by 2. That gives me minus 95.689325. So a squared is going to be 153.4752, take away answer, which is 249.1645245. Remember that because you're subtracting a negative, you're actually going to end up adding it. And then if a squared is that, then a is going to be the square root. So the square root of answer is 15.784. 15.784, and it says correct to 3 significant figures, so that would just be 15.8. So here we've got an upper and lower bounds question, and if this is the kind of thing that you hate and you get confused by, I'm just going to show you what you can do if you're like, I'm going to leave this question, so I'm going to show you what not to do and just literally how to get some marks even if you hate these kinds of questions. So first thing is you want to actually just consider the bounds, and I know that everyone can do that because it's just thinking about rounding. So a dog race is measured to have a distance of 2.8 kilometers, correct to the nearest 0.1 kilometers. okay? So it's 2.8 kilometers, correct to the nearest 0.1 kilometers. So all we do is we say, okay, what is the 0.1 kilometers surrounding 2.8, i.e. to 0.1 kilometers, in this case, it's one decimal place. So it's literally, what are the decimal places surrounding 2.8? That would be 2.9 and 2.7. Now the bounds, that would be the midpoint, okay? So the minimum value, it could be, the lower bound would be 2.75 and the upper bound would be 2.85. Now there's a lot of debate, and personally I think it should be 2.849 recurring, but just for simplicity we acknowledge that if it was an error interval it would be 2.75 is less than or equal to x, which is less than 2.85, but just so that for whatever reason we just say with bounds essentially it's the midpoint. So that's the upper bound for the distance, okay? So everyone can work out the upper bound and the lower bound. All you do is you write the thing and then whatever it's saying, so it's saying to the nearest 0.1, literally write one decimal place on the right, one on the left, and then you just find the midpoint. Then let's do the same for the speed. Now, okay, it is a little bit tricky because it's got like seconds and all of that, but 5 minutes, 45 seconds, correct to the nearest second. All we need to do is consider the seconds. So 45 seconds to the nearest second. What are the seconds surrounding 45 seconds? That would be 46 and 44. So halfway is the upper and the lower bound. So that would be 44.5 seconds and 45.5 seconds. So the lower bound for time would be 5 mins and 44.5 seconds, and the upper bound would be 5 minutes and 45.5 seconds. So that is for time. Now, this is a tricky question because it's just involving a lot of calculations, but hopefully the minimum that we can get is the upper and the lower bounds, and that's marks. You're just sweeping them up, okay? So I'm told that shadows, okay, so basically I haven't even read out the question. Essentially, a dog race is measured to have a distance of 2.8 kilometers, correct to the nearest 0.1 kilometers. So the distance is roughly 2.8 kilometers. The time is 5 minutes 45 seconds, correct to the nearest second. I've established my upper and my lower bounds, and now I need to work out the speed to a suitable degree of accuracy by considering bounds. Now, whenever you see this question, and if you, obviously this is quite last minute, so what I'm going to tell you to do, if you have the time, just work out each possibility. So for instance, in this case, how do you work out speed? Speed is distance over time. So you're going to have 4 answers. So you're going to have lower bound of distance divided by lower bound of time. You're going to have lower bound of distance divided by upper bound of time. Then you're going to have upper bound of distance divided by lower bound of time, and upper bound of distance divided by upper bound of time. So essentially you're matching each bound to each other. So there's a combination that includes all of them, and that will mean there's 4 combinations. So that is the worst case scenario, because all you're doing then is just substituting values in, and then you're going to get some answers and then you're going to figure them out. But that is the worst case scenario, and let's actually read the question because I think it actually wants more from us. So the key thing here is that it said speed in this race is something kilometers per hour. Now, his time is in seconds, so it's already kilometers, but it's kilometers per hour that is needed. So I know that 5 minutes is 5 times 60 seconds, because there are 60 seconds in a minute. So 5 times 60 is 300. Okay, so first thing I'm going to do is turn my time into purely seconds. So the lower bound of time is going to be 344.5 seconds. And the upper bound of time is therefore going to be 345.5 seconds. Now, what I'm going to do, because I need to convert this into hours, 1 hour is 3,600 seconds. So therefore, to get from seconds to hours, you divide by 3,600. So 344.5 divided by 3,600 equals, oh, this is nasty, but it's a calculator paper, so that's fine. So the lower bound of time is actually, I'm just going to write it up here because it's long. So the lower bound of time is 0.095694 recurring. The upper bound of time is going to be 345.5 divided by 3,600, which is 0.095972 recurring. Okay, so that is my time in hours. Whenever I'm dealing with speed, generally you're going to have to deal with your time as a unit of an hour. Normally it's minutes to hours, but now it's minutes and seconds to hours, but that's still fine. So what to do next? Right, so I know that is the time. I know the distance, so let's go back, and I know that speed equals distance divided by time. Now, either you do what I tell you to, which is you put all 4 options together, because then you can see you just have all 4 options and you don't have to do anything confusing, or you think about how could you get the biggest variation. So you essentially want the max speed and the minimum speed in order to figure out what you could round it to. So to work out the maximum speed, and this is where it's sometimes helpful to just pick 2 numbers. So if I literally picked 10 and 2. So 10 is my upper bound, 2 is my lower bound. What gives me the biggest output, biggest value? So 10 divided by 2 is 5, and 2 divided by 10 is 0.2. So when I do upper bound over lower bound, that gives me a max value. And when I do lower bound over upper bound, that gives me the minimum value. So you can use that shortcut if you already know that you just do these 2. If not, then just do all 4 options and you'll get something. So let's do that. So to work out the max speed, I'm going to do upper bound divided by lower bound. So upper bound of distance is 2.85. divided by lower bound of time is 0.095694, which is 2.85 divided by 0.095694 is 29.78229318 kilometers per hour. Which is pretty fast. Cocker Spaniels are very fast and amazing creatures. So the min speed is, I'd need the lower bound of distance, so that would be 2.75 divided by the upper bound of time, which is 0.095972 recurring. So let's just type that into the calculator. 2.75 divided by 0.095972 recurring. And that is 28.65412,446. So this is like the fastest way to do it, using those two. But like I said, if bounds is something that you struggle with, just do all 4 options. Like just mix them together, and then you'll get 4 answers, and then you'll be like, oh, well, to 1 decimal place, they all round to this. So it says by considering bounds, calculate the value of s. So this is the maximum speed. This is the minimum speed. Well, let's see. What do they round nicely to? That's a bit annoying. So it would be very nice if they rounded to 1 decimal place. So if I rounded it to 1 decimal place, that would be 28.7, and this would be 29.8. So I'd have to round it. If I rounded it to the nearest whole number, that would be 29, and that would be 30. So I'd have to actually round it to 1 significant figure. So I'd say 30 kilometers per hour to 1 significant figure. And if you had the other 2 values, you would have just got 2 values that are in between, and you would have come to a similar conclusion. But that is how we do bounds.